Greetings of the day to all the viewers of this video and welcome back to ptscadexpert and myself architect Kumar Kapadia from the city of Surat in Gujarat. And a humble request to all the viewers to thoroughly go through the introduction and explanation part before skipping to the main content of the video, that is the modeling part. So today's exercise is going to be all about modeling this G+2 residential villa using drafting and modeling skills with Revit with perfect precision and joint condition, following level of detail LOD 400, starting from the footing level to the topmost level, wherein we are going to incorporate structure in the modeling part, but this tutorial is not going to consider the MP part. So it is going to be a very informative session. Watch the entire tutorial till the end. And if you think that this tutorial was worth, then kindly enroll for this course, Master Diploma in Revit BIM, which is the combo of architecture plus structure plus MP. Fine. So whenever we start a modeling of a particular structure in Revit, the general process that follows is that we import the AutoCAD floor plans and model the 3D elements, particularly talking about walls. We follow the footprints and draw the walls, elevating it from the base level to the topmost level. But have you ever wondered that is that a correct way of modeling? Then the answer is no. Revit is a very technical software and is meant for the perfect modeling of the 3D elements precisely following the hierarchy and modeling of those elements exactly in the same manner how a structure is elevated on site, which eventually helps us generate a perfect schedule accurately, which will quantify the 3D elements and give its perfect costing, which I'm not just going to show you, but I'm just going to prove you with the help of a couple of examples, wherein you see that this is just a simple structure, G plus 2 simple structure. Okay, but if I just take you to this particular modeling part, if you just go to the floor plans, then what do you see that? If I just select, let me just hide this particular grid lines, HC. Okay, then if you just watch the modeling part, then you see that this particular 3D elements, walls, columns, and everything are wrapped with its wrapping layers, that is the plaster layer. And also the modeling part follows that this particular wall is constrained in plan exactly from here to here. Okay, it's according to its perfect location, and not only in plan, but if you just watch it in 3D, and if I just select this particular wall, then you see that the base constraint is ground level and the top constraint is first level with the top offset of minus 18 inches. That implies that if I just take this particular section, and if you just watch this, let me just again hide this grid line, and if you just watch this, then this particular wall stops at beam bottom. And another wall is casted, which is just a beam wall, which is excluding the masonry part and just taking into consideration the layer of plaster wrap to that particular structural element. Okay. And the same follows for the modeling of this particular other elements. And it follows the hierarchy and with the modeling of the element exactly the way the structure is elevated on site. That is a column elevated from footing and a joint condition with this particular beam, ground beam, and this to floor. And we have the finished floor layers and all of this its connection with the architectural element that is wall with its wrapping layers. That is the plaster layer on both the sides. Okay. And if I just take you to this particular floor, then you see that this is the drop slab, a typical detail of a drop slab which inverted beam. And if you just watch this particular floor, you see that there is a one tile drop between this finished flooring and this finished flooring. Okay. So if I just select this particular floor and if I just go to edit type, then you will witness all the associated levels with that particular drop slab. Brick beds, sand bedding PCC 20 then the binding element mortar 12 and then the finishing tile. Okay, so with this, the entire structure is elevated, filled with this particular terrace level. Now, what is the need of following this particular methodology or procedure for modeling of the 3D elements in Revit? So this will eventually help us generate a perfect schedule and perfectly quantify that particular 3D element, giving its perfect quantification and costing. which I'm just going to prove you and show you with the help of another simple example, wherein I just show you this particular thing. And if I just go to ground level, then sorry, not this particular project. This particular project is supposed to be minimized, and this particular project. And if I just go to this particular level one floor plan, then this is a very simple structure. It is a cube of 3 cross 3. Okay, this is a cube of 3 cross 3, which has been elevated up to the height of 3 feet. So, in order to round up the figures, I have modeled this particular simple structure in metric system because I wanted to prove you. So, if I just open up this particular schedule part, and if I just go to this particular wall schedule, and if I just come here and have a side by side view of this particular thing, then what do you notice? See, you will notice that this is a wall of 3.52. There's two walls. This wall and this wall is of length 3.52. So if you multiply 3.52 cross 3, that will give us the perfect area and perfect volume. And then if you multiply it with the cost factor, wherein this is the construction cost of a 2 brick thick wall in my neighborhood, that might differ in your neighborhood. So that will give the cost of masonry in that particular wall. With the help of that, we can also generate number of bricks. So you see that what level of detail and what information can we extract if we model this with the perfect precision in Revit. Not only this, if I just, these are the different joint conditions. This particular example, this particular example gives us different joint conditions, wherein you see that this particular three walls are 9 meters square, and exactly it is reading the area 9 meters square, 3 cross 3. So this was just to prove you that if we model with perfect precision and joint condition in Revit, then that will give us the perfect quantity and costing of the 3D elements. Okay. See, this particular wall is of 3 meters, but if I just take it to the 3D part, then this particular wall, if I just select any of this one wall, then right now this wall is selected. Let me just select this. Uh, let's select this. Yeah, fine. So this wall is selected. Now you see that the height offset is minus 4.5. So that makes the unconnected height 2.55. So if you multiply 3 with 2.55, then it will exactly give you this particular figure. Why? Because there is a beam over here which has been incorporated, okay, with the layer of plaster, which will give us not the cost of masonry for this particular beam wall, 0.26, with the layer of plaster wrapped to it. With that joint condition, it will not, we are not going to take into consideration for the masonry part, this particular wall, but that will eventually just give us the material quantity. And if I just take it into multi-category material takeoff, then this is all the list of different materials that are right now. There are only two materials. That is, one is plaster and another is this wall paint, which has been applied to different 3D elements. So not only that, if you just see that this is concrete, the amount of concrete that is going to be used in your entire project, it will quantify that too. Okay. So with this, if I just go to the multi-category takeoff, then using this features and functionalities of Revit, you can isolate and filter only the total amount of plaster that is going to get used in your entire project, which is going to get applied to the 3D elements. Okay. So if you cannot, if you cannot model with this precision in Revit, then eventually there is no point of using Revit because Revit is not a rendering software. It is a very technical software. Fine. So we today in Revit are going to model this particular project exactly using the same modeling skills and perfect joint condition and perfect precision, eventually creating this particular 3D model. Fine. So let me, before switching to the main content, the modeling part, let me just acquaint you to this particular project. Okay. So this is just a simple G+2 residential villa, as I said. I just take you to this set of drawings. Then, as I'm been saying that I showed you the precision and perfection with which we can mod, with which we can do the modeling of the 3D elements in Revit. But as I've been always saying, that Revit is not only about modeling of the 3D element, but it's very efficiently model the 2D interface also, which again has two bifurcations. The 2D interface, that is the creation of the drawings and all the essential details which is required for the execution of site. which is required for its execution on site. That is the scheduling and quantifying part. Okay. So talking about the 2D interface, first is the creation of different sets of drawing in different disciplines. For example, this is the site plan, then this is the floor plan, presentable floor plan, fine. And if I just go to this particular floor plate, then this is the working set of this particular same presentation floor plan. Okay, this is the working drawing of that, which involves all the details with all this particular 3D element tagged and the dimensions given. Okay, and these are the keynotes and everything. All the details is just follows with this particular revision cloud and everything. Okay, it also has the different layers of 3D part. But in this, you see that this is the exploded view of that particular this portion. That how is going to be your 3D roof going to appear with all its technical details and all the elements. That is the batons, common rafter, purlins, gutter, fascia board, fascia tiles, and ridge member and everything. Okay. It also has this couple of other features wherein you see that this shows the shadow pattern on your site with the help of which you can create a solar study. This is the exterior view, realistic view. But as I said, that Revit is not a rendering software, it is a technical software for the extraction of data, which data that persists to a 3D elements for its execution on site. But I will just show you that we can also create such solar views, solar study, which shows the shadow pattern and the impact of the sun on your site at a particular date and particular time. Okay. Not only for exterior views, you can do it for the interior views also. And you show that it shows the impact of sun and shadow pattern onto your interior spaces, not only in hidden view, but you can do it in your realistic view also. Okay. But as far as the rendering part is concerned, so as I just said that Revit is not a rendering software. So what can you do that you can create such 3D views, such rendered 3D views in Revit, but with much less time and with much less effort, you can create much more beautiful views and 3D views and animations in different plugins. Like this is done in Hardscape, but we have a lot of them. We have Lumion, we have Twin Motion. Fine. So Revit is not a rendering software, and you see that it creates such beautiful animations also, which you have seen in the beginning of this particular video. Okay. So coming back to this particular project, you see that it also creates this particular elevation, presentation elevations with the drop shadow and impact of the shadows, showing the depth that which element is the former and which is the later. Fine. So these are couple of examples of that. You can also create beautiful presentation and working sections in Revit. So these are the different sets of 2D drawings. This is the rendering view, which I just showed you. Also, you can create the drafting details here itself in Revit, or what you can do is that you can import an AutoCAD generated plan, because we as a designer are working on AutoCAD since years and we have a lot of details already established in AutoCAD. So there is flexibility of switching or loading the drawings here in Revit, and then what you can do is that if that particular drawing, AutoCAD drawing is in layered, then you can assign the line weight and your preferred hat patterns and everything here in Revit also. This is the area gross plan. Often designers are interested, especially architects, calculating the division of space, that what function is acquiring how much space, and that will eventually help them for the analysis. So this is the graphical column schedule. And now coming to the another part. This is the door legend and keynote legend, extracting of all the information of a particular project. And coming to the second part of the 2D interface. This was all about generating different disciplines of drawings. But you see that it is also used to extract this beautiful schedule, which on AutoCAD we spend hours and hours creating this particular tables and feeding information. If you feed this particular information to a 3D element perfectly in Revit, then it creates a beautiful schedule also. See, you can add all the different disciplines and different fields of which you can extract the information, creating this particular schedule. Just like that, you can have the floor plate, the window schedule. Not only that, a particular typical floor in Revit has lot of finished layers to that. So you can also generally have a material takeoff of that particular floor schedule, wherein you feel that this particular floor schedule is the this particular schedule gives the quantity of all the materials that are used in this particular project and it will apply to that particular floor. Of which, if you just want the quantity of mortar that had been used in that particular floor plates, which is used as a binding element, then it gives you the quantity of that also. Fine. And in last, you also have this particular beautiful sheet composition wherein you can model drawings of different disciplines and different scales. Of course, the designer will never issue the drawings in this format, but it's just to show you that drawings of different disciplines and different scales can be compiled together, creating this particular sheets. Okay, so just like that, we have this elevation views, we have the sectional views, and also we can generate a sheet with all the details. Clear? So this is the purpose of using Revit. So with this now, we are just going to elevate this particular simple structure in Revit, starting from in a fresh new file, starting from the base level to its topmost level. And for the modeling part, also I forgot to show you one thing, that you can switch between options, not only in 3D, but in 2D also. Wherein if you just talk about 3D part, then you see that this is a simple straight roof option, and that was the sloping roof option. And this same pertains to the 3D part also, where if I just take you to the presentation floor plan, and for instance, if you see that this is the furniture arrangement in this, and this is the primary option. So you can also switch between furniture options in floor plates also. And just take a bit of time to regenerate a very heavy file. So this is one option, and this is the another option. And let's say the client has approved the earlier option, so that is the primary option. Fine. So this was all about the features and functionality of using Revit for a particular 3D project. And with this, now we are going to start the modeling of this particular simple G+2 residential villa. And we are just going to take into consideration this option for the modeling purpose. So quickly, without wasting time, let's jump into the interface of Revit and let's start the modeling of this particular structure in a fresh new file. Let me just go to File and New and Project and just browse and just navigate to that particular folder, Program Data, Autodesk RVT 2025 and Templates. On that, we will go in English Imperial default and let's open a fresh new project template file. Now, what I'm going to use is that I'm just going to use the functions and features of Revit. And you see that this particular project has a couple of details already established with all the 3D elements, structural elements, and different types of wall assemblies and different floor assemblies already preloaded here, and door windows, etc., which I want to make part of that another project using the functionalities of Revit and also the material part so that we can concentrate on the modeling part and we don't end up wasting time creating that different assemblies and loading the materials. So I'll just go to this particular new project, and here under this manage, you have this transfer project standards. You can copy details from one project to another project, wherein I'll just say that copy from this live project September 24 batch, check none. And I will start copying, let's say that curtain wall types, then materials, floor types, all the different types of floors, where is it? And essentially the wall types, different types of wall assemblies. So with this, I'll just select OK. So if you now check this newly open template file project environment template file, if you check, then you will notice that all the particular details had been copied from that project to this project. For example, if I just go to materials, then you see that all the materials which has been created in that particular file had been copied here. So, and also if I just go to architecture tab and wall types, so you see that all the different types of walls have also been copied. Main wall, compound wall, then load bearing wall, and also the curtain wall types. So now we can concentrate on the modeling part, and don't worry, I will show you that how to create such assemblies and where to add the structural elements from. Now, within this, there are certain elements which were not part of that uh, transfer project standards. For example, this window, different types of ventilation, that is door windows, and also this 3D elements, that is this footing types and the structural framing, that is the beams and columns, column types. All this were not part of that transfer project standards. So we have to manually copy that particular things, those 3D elements from here. So I will just click this one door, one window, and this door, and also I will select the structural elements from here, and I would just by selecting them, I would say that I see that will isolate that particular category. With this, now I will select all of them and I will use a different function wherein I will say that copy to clipboard. So with that copy to clipboard, I will just go to this particular fresh new project and herein I'll just go to modify and under that paste align to current view. So with that, all the 3D elements, including the structural elements and the ventilations and openings, the door and windows, all will get copied within this newly created project environment. So the footings and all the 3D elements, structural elements have been copied, but the door windows have also been copied with just that you cannot see it because in order to host that particular 3D element, you need a host. And it says that couldn't find the host. So that's okay. But we are also going to delete this because I'm going to show everything of this from scratch. And now if I just go to this particular door, then if you just drop down, then you see that all the different types of doors are also loaded. And likewise, if I just click WN window, all the different types of windows have also been loaded from that project to this project. Fine. So now we can concentrate on the modeling part. So the first step follows is that we have to import the AutoCAD plan, AutoCAD drawing, and create the required levels. So what I'll do is that I will just close this particular project because that I just opened because I wanted to copy the 3D elements and the details. Now I'll just go to this level one and herein I'll just say that insert and import CAD. I'll navigate to that particular location where that AutoCAD drawing has been saved, that particular designated folder. And herein, I'll just open up that drawing footing plan. Don't worry, you will get this particular all AutoCAD drawings. And since this particular file is in feet inches, the import unit should be inch and manual center. And just click open. Fine. And just say that VG and import categories. And anyways, we are going to shift this to different levels. So now let's first create the different levels, required levels. And I'll just press LL and let's say that 6 foot, pick lines. And with that, I will just pick this. Again, I will say that LL, pick lines and 2 feet, create level over here also at the 2 feet. Then from that 2 feet, it should be the floor height should be 10 feet. So we'll change this to 10 feet and then offset 10 feet. That would be LL and pick 10 foot and just create one more level. And this would be slab top. Fine. And this would are unauthentic layers. The levels which you created newly are unauthentic. So how to make it valid? So just go to this vertical floor plan, select all of them and make them valid levels. Fine. Also, you need to do the same for all the different categories. This is the newly added feature in Revit 2025 that you have to create this newly added levels. You have to make them authentic this ways. So now I will just reduce this scale a bit so that we can view. And I'll just say that this to be footing bottom. And it will pop up this ugly sound. every time footing top. This would be road ground level. Uh-uh. This would be plinth level, would be first floor, terrace plan, and finally followed by slab top. So that is how you efficiently create levels in Revit. And you see that all the levels are created within all the disciplines, floor plans, ceiling plans, and all the levels has been renamed. Now, how to put this thing in order? So I'll just go to this browser organization, and herein I will just create a new category by level and just say that by sorting and grouping by family and type and associated level, and just click OK and just check this. So now you see that all the levels follow the order except for the site plan hanging around in space, but that's okay. Fine. So now what next to do is that select this particular AutoCAD plan and footing level and just drop it. Just say that work plane should be footing bottom. So that will jump to footing bottom, and I'll just click this particular footing bottom level and say that VG import categories and turn that to half tone. Apply and OK. So this is the sorry, sorry. Import categories and turn this to halftone, apply and OK. So this is the footing plan of that particular structure, wherein, as I said, that we are going to incorporate structure also. So this are a couple of isolated footing. This is combined footing. This is entire raft. This is step footing, and this is the strip footing, the structural walls, the structural load bearing walls, which are hosted with this particular strip footing. So as far as the structure part is concerned, all the details and all the considerations will be pretty much basic and conventional, wherein I might be partially correct or completely wrong, but the only motive is that just to show you that how can you incorporate structure while working on an architectural model in Revit. Fine. So these are some of the dimensions within that particular considerations which you are going to implement. So the reason of loading those particular families from that project was that only that we won't end up loading this particular families. For example, if I just go to structure part, then the first step would be I will just load this particular isolated footing. Then you see that all the categories of that footing has been already loaded because we copied it from different project. And if you want to see that where to load it from, then if I just click this isolated footing, or let's say that if you go to insert, then from load family, under RVT 2025, program data, Autodesk RVT 2025, and your version. You need to go to libraries and English Imperial since we are working in Imperial system. You can load each of the 3D details or 3D existing libraries provided by Revit from here. For example, these are the different types of doors. Likewise, we have this windows, different types of windows, and everything. I have loaded it from there only. We have just copied it from different project. And not just that, structural columns. These are the structural columns, which has this concrete, okay, concrete rectangular column. And just like that, for beam, we have this structural framing, structural framing, and we have this foundation, structural foundations. From where I have loaded that particular file and footing rectangular, I have loaded this and just giving it a different type according as per my drawing and as per my requirement. Fine. So now quickly, without wasting the time, I'm just going to go to structure, and first we are going to host the footing. So I would just say that isolated footing and 229 cross 36, and I will just give it a height offset of 2 feet. Since I want to view that particular footing when once placed. So what I will do is that I will just snap it here, and I could not find the snap points, but that's okay. I'll just get a modify, align this to this, and likewise I'll just copy it from one place to another place. And with that, I'll just shift the dimension and never do the mistake of moving it. Because while moving and snapping to the points, you might end up locating that particular element to the place elsewhere. So better option is that just align it. So with that, I will just copy the different columns from one place to another because I'm used to that particular thing. But you just follow the process of aligning it, move. Sorry. See, this is what happens. If it won't find the snap point, then it will not be properly positioned. Copy and copy it a couple of times. With that, we have here also one. So once place, you press space and you can rotate it and then move to. But see, if it doesn't find the designated snap point, then just align it. And with that, the footings with same orientation, you can just snap if you can find the snap point. And likewise here, these are the footings of different dimensions. Structure and isolated footing of different dimensions. I guess this one, 5 cross, or let's say that, yeah, 5 cross 5 feet 6 inches. So this is that. If just press space and move it, CO, copy it from this point to this point and place it. Now we have this combined footing, which also has been created with the same function, but just a different type, isolated footing. And this is that particular type, 29 cross 10 6. And I will just place it. And when it's placed, I'll just move it. And if you cannot find a snap point, just align it so you properly end up placing it. So this is how we have created the different isolated footings. Now is the time to place this particular uh, step footing. So there is a other a special way of creating this particular step footing. So I will just go to this particular architecture tab, and under that, sorry, not architecture, structure tab only. And under that isolated footing, yes, isolated footing, and this could be, no, sorry. Actually, I said that there is another type of it, and I started following the same process. Sorry, guys. So architecture and component. And when you have such custom type of footing, for example, you see that this step footing, and within this structure category, there is no different category saying that a step footing. We have isolated. This is the structural wall foundation hosted by a footing, and this is the raft slab. Okay. So what I do is that I will just create this particular footing by a different type, whereas I'll say that model in place and I'll say that structural footings. Okay. And we will use a different method, structural footing. We have foundations. Yeah, structural foundations, not footing, foundations. And I'll call this strip footing and extrusion. And I will just create an extrusion of 1, 2, and 3. So let's say that 3 foot and just finish it. So that is created. Now we need to create that particular steps. And in order to do that, we need to see this particular thing in section. So essentially, I need to create one section. Okay. And once done that, I'll just again go to model in place. And let's say that I will draw a reference plane over here. And with that PK, that is set plane, create and set. And the shortcut of that is pick a plane, PK, pick this particular plane, go to the particular designated section. And now in that you are in that particular sectional view. And I hope that I made a mistake. It should be 4 feet, I guess. Yeah, fine. And from there, I will just say that create and say that void extrusion and just come. But that should not be void extrusion. That should actually be sweep, I guess, void sweep. So for that, I need to go to the plan view, and herein I'll just say that create and not void extrusion. Sorry, guys, it should be void sweep. And wherein I'll just say that sketch path, and I'll just click this particular rectangle. And with this profile hosted on this line, and just say that finished. Select profile, edit profile, and go to that particular section. And from there, now create the thing which you want to deduct. So I will just say that come 2 feet, then drop 1 feet again, 1 feet, and Yes. So I guess that the 3 feet height of that particular fitting was correct. So let's just say that discard this and get rid of the command and again say that 3 foot. And that's why I have kept that particular file open so that we can have the reference of that whenever we want and edit in place. And I will just create this particular thing. Let let me see that in the section. Yes, and it's actually 3 foot. Yeah, 3 foot. Okay, so 3 foot. Yeah, and now I will say that footing bottom and say that create void forms. Sorry, select this, edit in place, create void forms and void sweep, sketch path, and create that particular path. And with that profile to be hosted on that line, just finish and select profile and edit profile and go to that section. And with that, just say that 2 feet, drop 1 feet, 1 feet on this direction, again drop 1 feet, and likewise you create that particular saying that you want to deduct so much of the portion. And with that, you will be able to create that particular step footing. Clear? So this is how you use the drafting skills in Revit to model different types of elements. So next is this particular load bearing wall with strip footing. So just I'll go to this particular footing bottom and herein I already have this wall WA and that would be this load bearing stone wall. And let me just go and check. Yeah, so this is that particular same wall which has been given this material, giving it a thickness of 15 inches, assuming that this is a load bearing wall hosted by strip footing. So this is the material. This is the material which has been given this particular texture. And if I just make you clear that how to create material in Revit is that if you press this arrow, say that create new material, so default new material, and just right click it and rename it XYZ, whatever. And then there are a couple of ways of loading material to this particular newly created material. One is that you need to come here and from this dialog box, you can load the ready-made created materials by Revit and just make it part of this particular project browser. And then you duplicate that material and use it. Another way is that we created that particular material. Where did it go? Yeah, here it is. Uh, couldn't find it. Yes, this is it. I'll make it appear like a wall. And here is the asset browser. See, if I hover my mouse, it shows that asset browser and it opens up the asset browser, which contains all the ready-made materials made by Revit under this appearance library. The extended version of this, more detailed and extended version, wherein you have lots and lots of material from which you can just replace the existing materials with the materials in the asset browser. Sorry, in this particular project browser. So with you can just, if I just replace this, it will be hosted onto that particular material, onto that the newly created material. What you just need to do is that if you don't want to mess with the materials of Revit, just appearance and duplicate it, and then you can do whatever customization you want to do within that particular material. But I would just say that delete. And that is how I have created all the different types of material for this particular project, of which one is just black stone, which has been applied to that particular load bearing wall. Fine. So what I'll do is that footing bottom and on the top constraint to, let's say that first floor. And with that, I will just create a rectangle with finish face exterior because it doesn't have a plaster thickness, assuming that there is the load bearing wall of homogeneous material, stone wall. Let's say that stone wall. Okay. So that particular wall has been created. Now, in order to host footing to that, what I will do is that I will just go to architecture and you have this structural foundation, creates foundation hosted by wall. So herein that type has already been designed. that is 3 foot 3 inches cross 2 feet. So if you just watch this, then you see that it is 3 foot 3 inches and the depth is 2 inches. So what I will do is that I will, not beams, that footing and that particular designated site, and then I will select all the four walls, and it will pop up this ugly warning and with ugly sound and this warning. But you say don't need to worry, that particular footing has been created. Clear? And if we just go to front, then it has also moved to its designated part, wherein the footing should actually be below its designated level. This footing are all of them are popping up because I have given a height offset because we wanted to visualize whatever footing we place in that particular floor plan. So that's why I had given it an offset of 2 feet, and that's why we can see it. Once we will host column to those footing, that will move to its designated level. And I will just delete this particular section. And now I'll just click this wireframe so we can see the columns. And now I will just use a different method to host the different types of columns. So instead of placing the columns manually and loading it one by one, what you can do is that you have this function in Revit wherein you can create this different types of grids and you can host the footings, columns on the intersection of this particular grid lines. So that is the use of grid lines apart from just being a mere center line or face line. So I will just say that, yeah, select the center of this and say that CS create similar and create this one, two, and this one. But you will have to rotate those columns after placing it, but that's okay. It's much easier task than placing all the columns manually. So with that, all the grid lines, now you can host the columns on the intersection of that particular grid lines. And with that, columns, structural columns, structure and column. And with that, you see that that particular column has been loaded, wherein these two are the different sizes of the column. And the reason of keeping this particular column size and the beams which will be attached to this columns will also be of different size. And the reason of that will be followed in the later part of the modeling process. That why did I made this particular column different size and rest all the other columns are the same size. These are the columns of bigger size. If you just measure it, we 1 cross 1. See, 1 cross 1. 1 cross 1 8 18 inches, 1 foot cross 18 inches, and rest all are 9 cross 18. 9 cross 18 conventional, which will be hosted within the wall thickness. And this will be the one which will project out and extrude out. Sorry. So now I will just go to this structure and column and first select this size 12 cross 18 and say that on grid intersection, and I will just post it. But you cannot see it because this option is selected to depth. I'll say that height and up to, let's first go only up till road ground level and grid intersection, and I will just post it. Oh, but sorry, I forgot to place a grid here. So how will it snap? One grid over here also that I would just extend. Okay, and now I would say that CL, that is structural column, and with that size selected, I'll say that all grids. And did I select that? Yeah, height and up to road ground level and all grids and just place. So you see that at with just one click, the four columns are loaded on the intersection point. You just say that finish, and I will just get rid of this columns. And this columns, you need to position it properly, wherein I will just click this align and align it properly to its designated location. And it's much easier process than snapping each and every column individually. And now they will do the rest for same for other columns as well. Structure and column, and with the other different size 9 cross 18 all grids. And I will just select this, and with one check it has loaded all the columns on the intersection. And this then I just click Control Z, and this grids also needs to be snapped. Okay, and CL and 9 cross 18 all grids, and just click and finish. Yes, and just delete this. These two are in place. Actually, all these three columns are in place, so you don't need to worry. Also, this one, this we don't need. This we need to rotate and flip the direction and just then move it at the designated place. Likewise, we also don't need this. And I'll just click here and try to find the snap point. And if I couldn't, then I will just align. And once that column's place, all the designated footings will go beyond the level at its designated level where it is supposed to be. So align and okay. This I don't need. This I again need to flip the direction. Only thing is that I need to align this face. Okay, and these two columns are hosted by this strip footing, which we need to move it in place. South elevation, and this should actually move, and this level should match. So I'll just say that constraint uncheck, and with this joint check, I will just move it 2 feet. So that will be at its perfect location. If you just go to 3D, then you see that all the structural elements has been hosted with that perfection. So just go to edit in place, and before going to edit in place, I should have copied the material. I keep forgetting the steps, but that's okay. Pardon me. Edit in place, and with that selected, press tab and just apply the same concrete material. So it should look the structural element and VG, and I'll turn this also to halftone in this view also. Structural element. Yeah, fine. Clear? So that is how we have created all the structural elements, and these two columns are actually not needed. So next step is that we need to lay the layer of PCC, because when this particular footings, this foundations will be hosted, first the leveling will be done and the layer of PCC will be created. And on the top of that, all the structural elements will be created. So what I will do is that I'll just go to again footing bottom. And with this, I'll just go to architecture and floor architecture, not floor architecture, sorry. It should be part of floor structure. And I would have already created that PCC, that slab of PCC, I guess. Where is it? I couldn't find it. And it would be created. Why I'm not able to see. Plinth level PCC. No, not that PCC. Sorry, we were looking for that at the wrong place. It is actually not created within this floor, but it is created within this structure tab and this particular structural foundation slab. And herein we have that PCC, layer of PCC, which has been given the material of nothing, just default, that's fine. But just a layer of PCC within that particular, I will just create all these particular rectangles, which would be the base plate for all the footings. And here I see the problem for orientation of the column. That's okay, we will correct it. Okay, and this should be snapped here. Okay, and all of this one I forgot. I will just give it a material of PCC, which has already been made, created by me, sand bedding PCC, which is nothing but you see that it has been given the graphics pattern of the sentence and appearance of this particular concrete, but that's fine. Okay, and apply and okay, and just no, but if we will give it a material of concrete, then instead keep it just default for now, right now. Apply and okay. and just finish. And we see that this particular column orientation needs to be flipped, move it, and also this two columns need to be moved as per the AutoCAD drawing. Only one column, yeah, fine. And let me just go to 3D, and all this particular PCC level should be moved at minus 2 feet 2 inches. Sorry, -2 feet. Yeah, fine. Clear? Now the next step is to give the tie beams, which is also again a structural concern, wherein I'm just randomly right now, you see that connecting that particular beams, all that particular footing, different types of foundations and footing with that particular tie beams at that particular designated level. But the actual location and the joint condition will be decided by the structural engineer. I'm just right now completing this modeling process and structure and beams. And I would just select this 9 cross 12. And with that, I will just say that snap. And the top of that should be laid on that particular level. And in order to visualize, let's say that bottom of that should be laid on that particular level. And Y justification to left or right. With this, if I just click, you see that left or right always shuffles. So that's fine. And all the tie beams have been created. These are the tie beams which are connecting this particular footing. Sorry. And if you just go to 3D, then you see that it is at a wrong location. So select SA, select one and all of them. And I just gave it a Z justification of bottom, saying that the bottom of that should be laid at that level. Just to visualize that, I will just say that the top of that should be at that particular level. And this either is, I'm not sure whether this is the correct location or not. Right now, I will just say that -2 feet, sorry, -1 feet. And let's connect it from the bottom in order to avoid buckling. So these are the tie beams which are provided to avoid the buckling. Fine. So this is only as per the modeling part. The exact position of this will be decided by the structural designers. Now, coming to this point, now we have to lay the ground ground road level. We have elevated this particular columns up to that particular designated level. Now, since we have a plinth of 2 feet, so we will have the beams, inverted beams of the depth of 2 feet. That is also again a structural concern, which will be hosted on this particular ground level, but will be inverted, which will act as the ground and plinth beam both. So I will just go to this particular, I will first take this particular AutoCAD plan and just say that, just send it to, let's say that ground road level. Yeah, that's fine. And then I will go to that particular designated level. Sorry. And herein I will just create that particular footings. Now again, you need to turn this AutoCAD drawing to halftone in each and every view you copy it to. And I will just say that HC hide in category. You don't need that, need to see the grid lines now. But essentially we need to create the footings. Sorry, beams. So I will just say that beam and beam of this particular 9 cross 24, which would connect this face. And likewise, this would continue, I guess. No, this would stop here because from here there is a change of dimension of that particular beams. Here that will continue. So just say that CS and copy it from level CS and just create. And here there will be different size of the beams, which I said is a not a structural concern, but a modeling part concern, which I want to show you that what difference. Just click undo, and I guess this is the, yeah, again it snapped to a wrong part. So left or right, I always struggle for this part. CS and then connect this to this. Okay, and let's just go to 3D and yeah, see all that particular beams have been created perfectly. And since those are the inverted beams, this won't go in bottom, but this will stay as it is. Now let's proceed on with the modeling part, wherein we have to move to the level above. And for this purpose, let's just take this particular at footing top. And herein, while coming to this ground road level, but I should have first taken a reference point wherein we can post the another drawing. So this now I will just take it to footing top, and at this place wherein only this beams exist, yeah. We shall insert and import CAD, and while going to that location, ground floor layout. And import unit should be inch and manual center and open. Fine, and just place it and VG and just imported categories, turn it to halftone, apply and OK. And this was the point, I guess. This was the common point, snap point, wherein I could not perfectly find. So what I will do is that I'll move. Yes. So with that, now we have to proceed on further with this particular floor plate. While going to 3D, let me just turn on this visibility of this grid hide in view by category, because that is creating a problem, disturbance. And here I will turn this to halftone as well. Okay. And the first step is that we need to create this particular compound wall. The thickness is 1 foot, assuming that this is also a shear wall hosted by a strip footing. It's just a structural assumption. And I will just go to architecture and wall WA. And from that, I would just select this compound wall 1 foot, main wall, 1 foot compound wall, edit type, and go to edit. And it gives given thickness of 1 feet, wherein this compound wall cladding, this material has been assigned to it. You can assign any material, that's not important. Apply and OK. And with that, I will just create this particular compound wall from this point to this point. And then while coming to here, I will just say that snap. And this would snap to the AutoCAD drawings. And there's a problem regarding AutoCAD drawing, I guess. Yes. So just ignore it. Just say that CS and continue from this point to this point. And again, this would be an inclined. Again, I couldn't find the snap point wireframe and WA. And from this point, I will continue. Join this to this, TR, and join this to this. Now, this two angular walls. So I'll just say that CS, and with pick lines, this perfectly snaps, but this doesn't. So what you can do is that we can just say that line and with the fillet radius, or let's just try to create this point to this point by snapping to center, center to center, and just no, but that's also not working. I get that finish face exterior to finish face exterior, and I'm not able to find the snap point. Let me just click here And then here, that too isn't working. Uh, WA, and with that wall, let's say that, or let's use another, let's say that fillet arch, this wall and this wall, and let's just create something which looks appropriate. Yeah, fine. And that is how we have created this particular curved wall. Now we need to host the strip footing to this wall as well. So I will just press HH temporary and say that structure and that's strip footing and 2 feet 2 inches, I guess, because 3 foot 3 inches was for this big wall. I said that for this it's 2 feet by 2 feet only. So one and two, and every time it is going to pop up this ugly sound. It's really annoying. But you see that with that, the strip footing has been hosted onto all that particular walls. I'll select all that particular walls, and the base constraint to be ground level, and I'll just give it an unconnected height of something like 5 foot. So this is the compound wall. Now for all this particular strip footing, there is a instance parameter eccentricity, assuming that there is a adjacent plot here. So we need to align this particular footing with this particular face. So how much is this? Let's just say that modify, and this, I just measure it is 6 inches. So I will just select this wall foundation SA, that will select all of that, and just give it an eccentricity of -6 inches. So that will move that particular footing in place with that wall face aligned. Okay. And now just go to ground road level and say that HR, and I need to get rid of this particular grid lines. I don't need to see it right now, so I will just hide it by category. And we need to create a lot of floor plates and lot of elements of this particular ground floor level before continuing with the modeling part of that particular plinth level. When you see that this particular inverted beams are coming up till plinth level, this is the plinth level. I'll just hide this particular compound wall temporary. So if you watch this, and if I just turn on the bulb, you will see that this is the plinth level. This is the plinth level. Okay, fine. So just let's proceed further. And first is that footing bottom. Oh, sorry, not footing bottom. Just go to ground road level, and we need to create the different floor plates within this particular ground road level, assuming that the backfilling and the leveling of the ground has been done. Once this particular columns elevated up to this ground level, all the necessary things have been done, and we have applied a level of PCC on this particular ground floor plate. Now we are going to create different floorings, different floor plates, different hardscapes. Sorry, not floor plates. To be very specifically speaking, different hardscape for the different for this particular ground road level. Assuming that the backfilling has been done and the leveling has been done, okay, and the level has grounded at that particular level, and the PCC has been done, we need to create a different hardscape plates. So I have created all of them, of which one is this floor architectural, and now I'm just going to say that which is this first parking quota, which is nothing but given this material of this particular material of square tiles, quota stone. It's just a JPEG image which has been assigned, but I'm just going to create that boundary line and pick this rectangle, and I will just create it from this point to this point, and then I'm just going to snap 1, 2, 3 TR and join this to this, and pick lines and join this to this. highlighted lines overlap. Yeah, sorry. And at that particular designated level, 2 inch, just an assumption, CC. Okay. Also, we need to cut this particular ground floor plate. So I will just hide this temporary, not ground floor plate. I mean the compound wall. We need to make a passageway or entryway for the car to step in, or the vehicles or the person to enter. So what I will do is that this particular thing, I would just say that edit profile and going to south elevation. No, sorry, not south elevation. I would rather just snap it from here to here and then again say that CS and pick lines, finish face exterior. Yeah, this and yeah, this I would just host it till this point. That's fine. Yeah, okay. But we need to continue this particular strip footing. So for that purpose, I will come to the ceiling plan of footing top. So we can see that particular footing, but due to the range level, we are not able to see it. So I need to go to the view range and say that this to be 3 foot 6 inches cut plane. And yeah, so see with that, we can see this particular. I will just extend this and continue and complete this. Okay, and this is created. This is wrong. I guess here I need to give the eccentricity of positive 6 inches. Yeah, fine. And that will properly snap to in place. Okay, and with this, now you see that it's absolutely perfect. And modify and just join this to this and say that switch order. And yeah, okay. Next part is that HR. And now we need to create the different elements. Very first would be this was entrance quota. Now architecture, floor architecture, and the pathway, which has been given the thickness of 2 inch and this material. So I'll just pick lines again, pick this 1, 2, 3, 4, and join the edges and have a close shape. And also we will have a pathway over here. So you can create all one at a go. And also there's boundary lines and from here to here. So these are the hardscape parts, which are the elements of hardscape, which will be the pathway leading to different spaces. And finish. R enter, and you see that it has been loaded. Stone blocks. Those are just the stone blocks. Next is that we need to create this particular gravel, this portion, which will be mud or gravel or anything, assuming after doing the PCC on it. So architecture and floor architecture, and this time it would be, where is it? I couldn't find it. Uh, which was that material? Come on. Plinth level PCC. No, not plinth level PCC. It was ground level PCC. Yeah, ground level PCC, which was applied the material of gravel. Yeah, pebbles, stone. Okay. So all of this entire site, major part will be that. So HL and just say that pick lines 1, 2, 3, 4, and a little bit of drafting work. So just stay tuned. join the edges. This would actually snap to here. hmm Pick lines again, and this would also be the same. Highlighted lines overlap, that's fine. We will get rid of that. TR jointed to this, and two times I guess we did the no, sorry, it was here. Yeah, fine, that's okay. Join this to this and join this to this, and TR and join this to this, and all of this, I will just say that finish. Yeah, so if there are lines open, then pop up an error. Yes, so that's done, clear. Okay, so now next is that grass, floor plate, and floor architecture. And grass, where is it? I just saw it. Yeah, grass. Pick lines, and this would be the gardening part, garden area. TR and join this to this. Okay, clear. Now what remaining is this particular landscape part, which would be at some height. And also, we need to create this walls. So WA and parapet wall. I would have already created that particular parapet wall. Edit, and if you just go to edit, and now if you see that, we will start adding the layers, wherein this is the core layer, 6.5 inch of plaster with the finishing material, and half inch of plaster on this end with the finishing material, internal and external. Fine. And if you just see this particular material, then this is it, black stone. Okay, so the existing material of Revit that has just been duplicated and renamed, loaded from here only asset browser. So just say that OK, and 7 inch, OK, and HL, and I would just create that walls, just 1 to 2. Created from this time. The location line should not be finished face exterior, but since it has layers, so that should be core face exterior or interior, and then create that. 1, 2, and here as well. Snap it. Okay, and here there is no, and pick lines, pick, and with that core face exterior, just pick this, pick and flip. Okay, and CS, and here too, and just connect it with this wall. Okay, and WA, and from here to here, and here, and here. Pick, and from this point again continue. This is actually the stair cabin, so this will end over here, and again start from this end. Not stair cabin, stairway, staircase area. Stair cabin, so stair cabin exists on terrace. This is again creating a problem. This is actually supposed to be delete, and just say that wall, core face exterior. Yes, the snap point is very important. Otherwise, you would end up in errors. Yes, and then pick lines. Oh, that's great. Okay, and this complete rectangle. Yes, also this. Okay, from which we will just eliminate this walls. Join. Yes, and here it will. Here there will be a wall. Sorry. Okay, but here there are no walls. Okay, clear. And now this particular beam is on ground road level. So yeah, that beam will come. Doesn't matter. So I will just select this particular SA, all this particular walls, and say that unconnected height, not 5 feet, but just 27, or let's say that just 2 feet, plinth level, after plinth level. Fine. Okay. Let's, what next? I'll just come to this particular road level. And yeah, we need to create the landscape plates for this particular areas, grass plates. So road level and again floor architecture and grass, but this time the height of such should be 15 inches. And with that, I would just create all the required grass plates, wherein actually there will be filling and then the grass will be cultivated there. But we are talking about the modeling part and this rectangle and this rectangle entire from here to here and from here to this point. This should be actually snapped over here. TR and join this to this. TR and join this to this. And create this rectangle as well. And pick lines and pick this TR and join this to this. Okay, so here also remains. So one, two, three, four, and all of this. TR join this to this and just finish. Lines cannot intersect, which continue. And yes, here there is proper, everything is proper, I guess. Yeah, this remains. So let's just do the needful by pick tr, join this to this. Okay, yes, and just finish with the height offset to 15 inches. Don't have overlapping lines. Still, continue. Still, fine. So that's completed. Okay. So the glass plates has been created, and here I forgot to draw this particular wall. So CS and go to road level, and let me just core face exterior and just do the needful. 3D. Yeah, fine. Yes. From this point now, we need to lay the rest of the other ground beams, which will be used to support the extended plinth and the hardscape areas, wherein the exact size of the structural elements, that is, this beams and the connection and everything will be the resolution will be given by the structural engineer, but we are just considering an ideal situation and following the conventional modeling method. So in that case, if this is the ground beam, we need to extend it to this point and say that CS. And from this point, I will just draw it again till here. And then I need to pick lines and flip the direction, say that to right. Okay. And CS again, left and right. This is always line. So from here and CS and chain should step down. And why didn't? Okay, until here. And let's just connect this here. And likewise, we also need here. Again, this should be right. The Y justification should be right. Yeah. And CS, this point, and also connect this to this. Again, this is left from here to here and from here to, if this is not, yeah. Okay, and also this entire stairway. So just select this and drag it till this point. And CS and just pick lines, right, right, and pick lines is much easier method. But sometimes in that, if you might happen to click somewhere wrong point, then you might end up snapping somewhere else. And this is now creating a problem. So TR and join this to this. Yes. Okay. And where else do we need that? Here, here also there will be a beam of smaller size, but we will just consider an ideal situation and we will have filling over here of brick beds. Okay. Now what left is this point should be continued till here, and then again CS and from here to here. Yes, okay. Why is this? Yeah. So we need to join to this point because this wall is considering the external application plaster layer also. So we need to consider the unfinished surface in order to have flush connection. So with that, we are done with the laying of beams. Okay, now let's lay the floor plate, and actually let's consider this also. CS and from here to here and from here to here. Okay, so with this now we need to lay the floor plate on plinth level, but we cannot see anything. So let's just turn this underlay to ground road level. And yes, with that we can see the footprints. And this grid lines, I will just say that hide in view by category. Okay, so the clear floor plate we can see. Now, what we need to do is that we need to create the floor plate for this particular floor, plinth level, not this, but not ceiling plan, but essentially this level. Yeah. And on to that, I will just click this and say that hide in view by category. Okay. Wireframe. And let me just say that the ground range level to be ground road level. And with that, we can see the AutoCAD plan. And if the purpose of that particular floor plan, AutoCAD plan on that level is complete, then what we can be do is that we can just select this particular ground floor plate, ground floor layout, that is AutoCAD drawing, and just change its work plane from road ground level to plinth level and just elevate it. So while going to plinth level, now I'll just say that import categories and turn this ground floor layout, AutoCAD drawing to half tone, and just change the underlay which was not actually needed, just say it none. So we'll have a clear visible floor plan onto which we can load the floor plate. Now I will just go to this particular floor architectural, sorry, it should be of the category floor structure, and all the floor plates exist, whether you select floor structure or floor architecture. But if you will draft this and model this wherever needed, if there are the finished flooring areas, then you should go to this particular floor architecture and then host that particular floor and then model that floor. But if it's a structural element, then come to this category and then host that particular floor. And since this is going to be the structural floor plate, so what it would be? So that would be this ground level, plinth level PCC, plinth level public areas. No, sorry, plinth level PCC slab. Okay. Now the difference between RCC and PCC is that generally, the ideal practice says that when there is a plinth of 2 feet or 18 inches and there is a ground below, so you generally don't cast the RCC slab, that is the reinforced cement concrete, and only the reinforcement occurs on the overlappings, that is on the intersection of this particular columns and beam grids. Only the reinforcement will pass, and rest all is the PCC, that is the plain cement concrete. And if it is a floor above, then the slab has been casted. So generally, that is again a structural concern because in today's regular day practice now, people have started casting the RCC slab on ground floor also, on plinth level also. Even if the plinth is 18-inch, then according to structural concerns, they cast the RCC slab. But ideal practice or whatever that depends upon the structural designer and the load calculation. So we will just consider this plinth level PCC slab which has been given the thickness of 6 inches, and the material here is this sand bedding PCC, which is of the concrete only material. But the important is that the graphics pattern is not concrete, but it's sand dense. Whereas in case of this first floor RCC, if you will just see that this is concrete cast in case gray, the material, okay, the same material, wherein this is the hatch of the concrete and this is the actual material, okay. So let me just say that plinth level PCC slab, and then I will just select this. Let's draft out the entire cube first, and then we will just do the needful, the required changes, wherein this on this point line, and we need to do a lot of drafting work now. So TR and join this to this, and LI and TR and join this to this. Okay, and line, and from this point we will have it till this here and pick lines, 1, 2, and Li, and complete the shape. Also here Li, and this would be the shape. Pick lines, Tr, and join this to this, and this line will not come. And essentially Li, this point would be here Li, and this is the water body. Okay, and just connect this. Fine. So this is the PCC floor plate, and actually this will also come. Yes, sorry. Li and Tr, and join this to this and join this to this. That will be excluded in floors above, but on ground floor, this will exist. Okay, and with that, I'll just say that finish and drafting errors. Yeah, we need to Li and create this. Finish. Still, okay. You shouldn't have any open edges. And yes, with this, you see that since this is casted as concrete floor slab, so this one-way, two-way direction symbol annotation pops up, and they say that hide in view by elements, and R enter, and so you see that this is the concrete slab that has been casted entirely. Let's go to 3D. Yeah, fine, perfect. Okay, now wherever necessary, we need to check the join conditions, and yeah, fine. Okay, so this is the PCC slab that has been casted on the ground floor, and I'll just go to this particular ground road level. And now, before proceeding further ahead, okay, let me just first complete this staircase and also this missing elements. This would be ground level PCC only, CS, and here this also would be the same, but at the height of from road ground level, it will be at the height of 15 inches. It is a see-through from this particular washroom, some courtyard sort of thing, wherein here the wall will be only of 9 inches. Okay, so this is R enter, and yeah, I should have edit boundary and HL selected the internals, because here there will be a curtain wall, so not wall plate, curtain wall, R enter, and what is remaining is now the stairs, ramp, and also this water body floor plate. So again, I will just go to floor, and this time floor architecture and water body base plate, yeah, which would be resting on ground itself. And let's give it an offset of 0 and just finish it. Fine. So now we need to just complete the staircase in order to complete the missing portions of this and this ramp. So I will just go to this particular stairs and say that monolithic steps and round level to plinth level, and this particular dimension says that how much it is. Oh, it is an ugly fraction. So what needs to be done is that I'll just measure it from this end to the unfinished end, 11, and some ugly fraction it is. So right now just say that run, and with 3 foot, or let's say 8 foot of width, I'll just click the center, and how much of them, 1, 2, and 3, and what is the tread depth, that is important. 1 feet, 1 feet 6 inches. So again, go to modify steps and run, and run width is 8 feet, but this is desired number of stairs Desired number of risers are 3, and this is 18 inches. Okay, and road level to plinth level, and yes, desired number of risers should be 4. Sorry. So with that, you finish this and just come here and stretch the run run width, and just finish. So that particular staircase has been created, and we don't need this railing. I'll just delete it, and this should be. Let me just go to edit type of this 3/4 inch of a nosing and get rid of this slanted risers, and nosing length also I'll just say that 0 for now. Okay, and the monolithic material should be right now. I'll just say that stair material. Okay, and just a color, not going to the depth of 6 inch is the structural depth. Apply and okay, apply and okay. Fine. So that staircase has been created. Now I'll just go to ground road level. Again, say that CS, and this time the run would be from this end to 1, 2, and again, I guess that this is 1 feet 6 inches. Yeah, fine. So what is the issue? Run and actual run width 8 feet. Desired number of risers 4. Actual tread depth 18 inches. Since this is an instance parameter, so you need to change every time instantly. Okay, and with this, I will just say that convert to sketch base. That's fine. Edit sketch, and then I will snap to the unfinished surfaces. Yes, okay. TR and join this to this. Extend this lines, riser lines. TR and join this to this. And where would be the another boundary line? So here I will just say that click this point here and this over here. Unjoin elements. Yeah, that's fine. Okay. And for risers, I will just say that riser and pick lines 1, 2, 3, and 4. And also pick this, not the boundary line, riser lines, pick 1, 2, 3, and 4. And just TR and join this to this. Risers 1, 2, and this does exist. And this is the stair path. And just finish. Edit type and structural depth 6 inch. Fine. Stair material, everything is fine. And finish. Invalid sketch. What is the issue? Oh, this needs to be joined. Still, the stair path which is connecting the risers. Yes, that's fine. What the issue? 6 risers created, 2 remaining. Hmm, and let me just check. Yeah, everything, the shape is complete. And just finish. Yeah, fine. Sometimes Rabbit behaves weird. Yeah, substrate material and fine. Just finish and go to 3D. So that steps has also been created. I just need to get rid of the railing. Now what left is this two, this three actually. So I'll just go to road level and select this and say that CS, that is create similar. What is the width of this? 10 foot. So modify staircase run, and the actual run width is 10 foot. And this is also 18 inches. So instance parameter, which you need to change, modify stairs or run. Yeah, you need to click the run and actual run width 10 inch, and this is 16 inches. And from railing, I will just say that none and okay. And with this, I'll just click this center, and also the tread depth, actual tread depth is 18. and just finish. 1 to 4, that's fine. It's created. CS and just measure this 1 foot 6 inches, that's fine. But this unfinished, oh, it's ugly. So I just need to say that run and 18 inches run and just snap to the center and just create it. Once created, I will just stretch it to the desired location. Okay, and just finish. Last one, this to this. This is also, so doesn't matter. I'll just say that CS and the run both would be 5 feet run and 18 inches run from this point to this point, stretch it, okay, and finish. So with that, all the required elements, needed elements are complete. What we just need is this ramp. So how to create this particular ramp? The desired height is we will lay the finished flooring onto this. So we will lay this particular ramp later once we are done with the finished flooring. So we can actually manipulate between the height. Otherwise, the ideal thing is that if it is going from road level to plinth level, so 2 feet of inclined ramp length, and within that 2 feet, you need to uh, sorry, inclined length of this ramp is this ugly fraction, which I will just say that Li and Li. Actually, for accurate, you need to convert this to mm. So I will just go to UN and just change this feet and fraction and just minimum millimeter, rounding up to two decimal places, and just measure this. This is not giving the dimension. Let me just click Li. Yes, and 2682.90. I will just copy it and divide by 0.60 because 0.60 is the 2 feet is of the plane. So in calculator, you need to set with the calculator. If you just say that calculator, okay, and just I'll paste the figure divided by 0.60, not 0.60. So that will give you this. No, sorry, that is in mm. So not 0.60, sorry, divided by 60, 60, 600. So 4.7715 is the 4.7715. I just go to this particular architecture and not stair, but RAM and edit type. And this should be solid. And the maximum inclined length is this. And that divided by height will give you 4771.5. That is the ramp max slope. Apply and OK. With this, if I just draw from here to here, you see that it has been created. And I'll just snap it. OK. And I'll just again go to railing and just say that none. Okay. And this is the stair ramp path. And the ramp is not enough. That's fine. What is the problem? If I just go to edit type of this, then not 4771.5, 4.7715 and apply and OK. And with that, just finish. Yeah, see, the ramp has been created and edit type. And I'll just give it a material ramp material. It already exists. Okay, apply and okay. That's fine. Okay, but we will have a little bit of, because the finished flooring will come on this, so we'll have a little bit of glitch because the height is calculated to be 600 mm and the max ramp slope was calculated on the basis of that height, but actual height will not be that. So that's okay. I think that you understood the concept that whatever is the height divided, whatever is the inclined length, that divided by height will give you this max ramp slope, which you need to enter here. Okay. But essentially to do this, you need to convert the units to millimeters. And I will just now again switch back to feet and fractional inches, rounding up to 1/4 of an inch and okay. And okay. Clear. Now what we need to do is that we need to create the finished flooring of this particular ground floor PCC created. Okay. And I guess that I missed this particular floor plate. Okay. So what we just need to do is that select this, go to plinth level and just edit boundary. And actually, this would be TR and join to this, and this would be, yeah. And from this point, it would be complete this particular floor plate. Just get rid of this line and also this line, and also this line. Get rid of this. This entirely would be the floor plate. Okay, and just say that finish. Yeah, yeah, yes. Okay. So now with this, we need to lay the finished flooring of this particular level, different levels of this different areas, the finished flooring of different areas within this particular floor plate. So what I'm going to do is that I'm just going to snap to the AutoCAD lines wherein you will see that all the finished flooring has been created. And with this now, I will just select this particular floor architecture. And let me just look for plinth level, plinth floor entrance deck. Go to edit type, go to edit and plinth finished flooring public. So this material has been applied to it. This is just a JPEG image which has been applied to it and it has been renamed, wherein the consideration is it will be just be a mortar 0.5, that is 12 mm, and this would be the 19 mm tile finished flooring, so that 0.75. Okay. So since this is a ground floor PCC and this area below this area is the filling, the ground. So the consideration is that we don't need the brick beds and sand bedding layers. What we need is that on the PCC floor casted, what we just need is the binding element, that is mortar, 12 mm, and then the finishing material. So that is the consideration. Apply and OK. For all the finished flooring of this particular level, we will consider this only. So with that, I'll just do the needful and this, yeah. So this line LI and just create one, two, and again you need to snap to pick lines and pick this TR, and actually this will connect here, but I guess that this would be an invalid sketch. This would be an invalid sketch. Okay, forget it. Let's try here. Let's complete this first. One, two, and pick one, two, line, and okay. So this would be the Plinth floor finish area. And if I just try to finish, yeah, see, so this is creating a problem. Mm, I guess this floor plate will have to create differently. And I will just select all of this and just say that Control X and join this to this and finish this and complete this. At least highlighted floor overlaps. That's fine, but we need to give it a height offset of the thickness of the finished flooring that we created. And what is the 1/4 is the thickness. Fine. So herein I'll come to this particular plinth floor entrance deck and give it a height offset of 1.25, that is 114. And yes, so R enter, and you see that it appears HL hidden line. And I'll select this and say that CS, and then I will just say that Control V, so we don't have to do that particular drafting again. Move it from this point to this designated point, and just have a line over here and finish. Again, the same problem. So 1.25. Yes. Rest. Let's complete the other parts, wherein this is the okay living areas, public areas. So HL, and again a little bit of drafting. So again, I'll say that CS. Sorry, not that CS. I just say that architecture and floor, and the floor architecture and plinth area, plinth floor public areas, edit type, and go to edit. And this again will be zero point 0.5. This we have taken it from another project wherein I was working in MM. So that's why this glitch. First floor public, and forget about this name. You can just rename it. But first floor public, this particular material has been applied to that. Apply and OK. And you can actually create a duplicate of that. Wait, and just say that no, and edit, and just create a duplicate, because that will help in quantification. So duplicate material and asset, and I would just say that ground floor, sorry, plinth floor public 2, because there already exists one material that, and within this appearance go to duplicate this also, and call this plinth floor public 2. Yes, and just apply and OK, and OK, apply and OK, and now a little bit of drafting work. It's very first we will just snap it from here to here entirely, and then the rest of the other lines also from here to here, LI, and just create this sketch. And from here we need to get rid of this extruded column, and say that okay, fine, right now let's just, then we will, when we do the clash detection, we will just solve this. Okay, and this is going to be the print code public area, and just finish it. Oh, sorry, I forgot again. 1.25, that is 114. Yeah, R enter, and you see that this is the flooring. Likewise, I will just go to floor architecture, and again, I'll say that public areas, public plinth floor, private areas, which has been applied this material. Again, that has been applied the material of first floor private is that taken from another file. So that's why duplicate, and just call this plinth floor private, and just copy this much, appearance duplicate there also, plinth floor private, apply and OK, and OK. Yes, we need to change this. zero point 0.5 of an inch and 0.75 of an inch. OK, apply and OK. And with that, I will just create modify boundary lines, drafting tools, and from this point to this point, connect this LI, TR, and join this to this. This much portion will be anyways, when we join geometries, this will be eradicated. So don't worry about it right now. This would be the for this. And yes, private area the only this much. We can actually consider this also as private area, but it's waiting, so that's fine. Okay, and just give it a height offset. This time I won't forget, so you don't pop up that error and that ugly sound. R enter. Yeah, fine. Now washroom tiles, and I'll just say that floor and HL, floor and floor architecture, and washroom, water body, water, and plain floor, washroom floor plate, edit type, edit 0.5 and 0.75. Yes, and this particular mosaic tile loading material has been given to it, ceramic mosaic blue. Okay, and apply and okay. And that would persist within this floor plate. That is from here to here. Also, we need to consider this Li, join this to this and join this to this. And the same over here as well. Li and create this and join this to this. Okay, and give it a height offset. That's fine. Washroom floor plate. R enter. And which material has been applied to this? Let me just check. Okay, that has been applied this same material, Plinth floor public areas. So I'll come to this project 2 on which we are working, edit boundary and HL and consider that also and finish. Now within this, what you have is that you have a deck and some steps which will be leading to this area, which we will create using component and model in place and floor. And just call it deck and pool steps. Okay. And we are going to create it by extrusion. So I just say that extrusion and just create it. That would be 6-inch extrusion 0 and extrusion end, extrusion start. And also we need to consider the thickness of that particular finished flooring. But I will just see that finish and finish. And this particular flooring which we created, where is that? R enter. And this particular flooring, I'll just say that edit boundary. And from this, I will just get rid of this much. 1, 2, and 3. Split lines, TR, and join this to that, and join this to that, and just finish it. WF, and you can also have within this, you can call this 3-inch and create another extrusion. That would be 6-inch, and that's fine. Okay, so that's why the deck has been created. Okay, now we need to create this particular pool steps which will lead to this pantry area, connection between these two areas. So I'll just say that randomly, I would just create this at the work plane is right now set work plane, and that would be not plinth level but road ground level. Okay, and with that, I will just randomly create two steps, one over here and one over here. Okay, okay, and the extrusion start should be 0 and extrusion end should be something like let's say that 18 inches. We will exactly decide its height later on, and that would be this material, plinth finish flooring private. Yeah, okay. Rename and plinth finish flooring private Actually, not this, sorry. We will just rename this, calling it 2, copy, and 2. Just call it 2. And this I will just rename, calling it Plinth Finished Flooring. Let's be specific. Okay, and we will select this Plinth Finished Flooring 2 and just apply that material to this and finish, and also this and this should be applied the same material. Then finish flooring private too. Okay, and finish. We will look onto the height of this later on. Right now, just once we start with this particular wall, and then we will decide its height. But now what we need is that we will go to this particular plinth level, and herein I will just create one another floor plate, edit in place, and that would be create extrusion, and just create one and give it a height of, let's say, uh, 15 inches, or let's say 14.5 inches, and this would be 15 inches, and that would be given the material of water, existing materials of Revit, finish. Okay, so that would look like there is a pool and there is an access to this area. The height of this we will change it later. Okay, so with this we are completely done with the flooring part of this particular plinth floor area. Now we need to start elevating this particular structure further from this level. So what would be the first step? The first step would be that I will just select all this particular different types of column. Just select this putting and hiding view by category. We don't need to see that. All of this particular columns, and you see that the top level is ground road level. Let's turn it to first floor. So things will be easy now since we have created a lot of details. Okay. So once this column elevated, the next step would be to build the walls or the structural framing. What? Let's go for the structural framing first. Okay. And all of this concrete 12 cross 24. I just select SA. So that will select that, those 4 beams. And I just say that copy to clipboard, paste, align to selected levels. And I'll just paste it to first floor. Okay. But herein, this particular beams at this level was acting as an inverted beam. So that's why if you select this beam, then it's justification for Z justification for bottom. But here, that won't be the case. So here, I just select all these 4 beams and Z justification to top, saying that the top of that should be laid on that particular level. Okay. And likewise, all the other beams, for example, this concrete rectangular beam 9 cross 24, I'll just select all of them SA and just say that copy to clipboard, paste align to selected levels. And from there, I'll just change it to first floor. Okay. And I will just select this SA. That will select all the beams of ground floor level also. So I need to make a cross window and deselect that. And herein, I would just say that the Z justification to top. And the same mistake I did here, SA, and just deselect this. And for this 4 beams, the Z justification should be just proper. Uh, 12 cross, yeah, that's fine. Okay, it's proper. Let's just isolate this much IC and look whether it is perfect or not. Yeah, it is absolutely perfect, no issues. Let me just go to south elevation and check HC. hide this compound wall and that beam. This is the parapet wall again, which I don't want to see. I want to see this concrete beams and the bottom of that has been laid. Yeah, that's fine. Perfect. So you see that this is the beam and it is popping up at properly at its place. So this ways you see that we have elevated entire structure part to the next level. So things will be easy now. This again, I need to select and just change this to bottom or let's say the top. Yeah, fine. So why is that not? Let's give it a Z offset value of 2 feet. It's not, it's creating a problem. So what to be done? Just delete it, select this again and say that copy to clipboard and paste align to selected levels, first floor, but I'm talking about wrong place and I'm just changing this doesn't, so not to worry, we will create that particular thing again, but do we really need that particular projection there? Let me just go to 3D of this complete project. Yeah, fine. So see, we actually don't need only this particular beams. We don't need at that floor. So why unnecessarily use energy? Okay, so some of this beams we don't need, which we need to check while going to that particular designated floor plate. That we will do it later because I know that we don't need this. So I delete all of this and this I will just say that TR and trim. Okay, what we need is this much only. Fine. Now within this particular designated level, you see that this is the floor plate and herein some of the areas within this will be exposed when a person is standing over here and if he is seeing then he will see this particular concrete layer. So what we need to do is that we need to hide this particular concrete layer by wrapping the layer of wall onto this in a such a way that the plaster is on one side and will act as a beam wall for this particular designated level. Okay, this particular designated level, it would act. You see that the particular surface is right now acting, showing this particular concrete, but it should actually appear like this HR and just take a bit of time to open. Yeah, so you see that it should show this finish. So see, ground beam external wall 9-inch plaster, which is a wall which is actually a wall which has been wrapped with the plaster layer only on the exterior side. Clear? So that we will do. Just click undo again until you can see the structure part which we need for reference. So let me just go to this project on which we are working. And I guess that we don't need to see this particular AutoCAD plan in this view. So I'll just select it and hide in view by category. And now we have to snap the layer of plaster by applying that beam wall onto this particular exposed surfaces of all the beams which are visible, the concrete of which the beams which are visible. And here I guess H and let me just watch this point. Sorry. Yes. So this beam should actually divert here because there is a s- stair staircase portion onto here. So I made a mistake. So I'll just go to the particular plinth level and I cannot see it. So essentially I need to go to, let's say that ground road level. Okay. And there also I cannot see a H and this particular beam. Yes. So wireframe and this particular beam, if I just select it, it will stop at this point. And from here, it will continue CC or let's say R enter. I will just select the particular beam CS and HL, draw it from here to here and here, but this has been wrongly created. So again, the left right justification and connect it here. Fine. And let's go to 3D and check. Yeah, fine. So that's better. Again, this, I guess that it should be left. Okay, clear. Fine. So that was one mistake. And now I'll just say that HR. And yeah, fine. Perfect. Now we need to snap the beam wall to this exposed beams which are visible in this particular at that particular designated floor plate. So I will just go to ground road level and I'll just hide the AutoCAD plan first and just say that hiding view by category and just go to structure and beam, and I already have that particular, sorry, not beams, but I'll just say that go to walls, and I already have that particular wall which I just showed you in that another project. Beam wall, it is actually going to be the beam wall external plaster 9 inch. So you see that that is not that particular beam wall. Beam external wall 12 inch and ground beam, yes, ground beam external wall 9 inch and ground beam external wall 1 foot. So I will just select this particular external wall 9 inch for first. Okay. And the height of that would be from road level to plinth level. That's to 2 feet of height. That's enough. Okay. And wherever needed, I would just go to core face exterior selected. I will just snap this layer of this this wall with the layer of plaster. I'll just snap it. Okay. So with this one created, if you now see that, you see that this particular beam is wrapped with the layer of plaster. And if I just go to modify and join, select that beam and select this wall. So no, but actually we need to do it for all the external visible beams at that particular designated level. So we will do it once and for all. And even if you just watch this point, if I just click Control Z, then you see that because this is a wall and you created a wall, I'll just Control Y. You see that this particular thing has. So we need to work on all these joint geometries and do the required changes. But before that, let's first snap this particular beam wall to all the external beams that are visible. So I will just go to the road level again, and with that wall selected, ground beam external wall 9 inch plaster CS. And with that same, I would just create that from here to here and here and all the way till this particular point. We'll stop it here. And again, we will start it from this point and pick, sorry, two at a time. Sorry, CS and line. It should be line. And I hope that I'm not making a mistake. Let me just check. So here somewhere there is a problem. Yeah, so this particular for this surface, it's snapped to the wrong location line. Here it is perfect, but from this point, these two walls, 1 and 2, I'll just delete it. Again, go to that road level and select it CS, and with that I'll just flip the direction and create it once again. Check. Still, it is creating a problem. The location line is the problem. Yeah, fine. So, okay, I got it. The snap point of that particular wall, because the plaster is on exterior. So you have to select that and say that CS and snap to this point. Yeah, perfect. One and two. Likewise, here too. One, two, and pick. And all one and two and three. Okay, from this point, now we need to change the category because this all are the bigger beams. So ground beam, external wall plaster, 1 foot. And with that selected, you see, okay, and okay, see how the layer of plaster wraps. And this would again be the regular 9 inch from here to here. Okay, and now if I just go to 3D and if you see that all the surfaces of that particular concrete beams, which was earlier visible, is not visible now because of that particular beam wall with the layer of plaster wrapped. Clear? So with this done, now we need to do a lot of hard work for the joint geometries, and also I will just show you the clash detection part, which we can do here itself in Revit by going to this view tab, sorry, collaborate, and here this interference check. Okay. And the LOD 400, which we were talking about, the perfect joint condition. In order to perfectly quantify the materials, we need to do a lot of hard work before proceeding further, wherein we need to join a lot of geometries. Okay, so let's start with that. And for that purpose, what I need to do is that I'll just close this inactive views, just go to this particular Plinth level and drop a section. And now with this section, what we need to do is that we need to check the joint conditions of all this particular 3D elements with one another, whether it is of the same discipline or of the other discipline, whether architectural to structure or architectural to architectural. But we need to check the joint condition and get rid of the overlapping volumes at the possible junctions where you think that there are two different materials overlapping with one another. Okay, so just let's start with this particular first, and you see that here we need to, these are the obvious join conditions which you can do here itself in 3D also, that is join this to this, and let's do it quickly for all the 3D elements herein. And once that joined, what you need to do is that you need to switch the order, so modify and join and switch order. And for all those 3D elements which you just join, you need to switch the order. Okay, and CC R enter, join and switch order. This will result in perfect quantification of those particular materials. Clear? And R enter. Fine. So now let's go to Plinth level, and this was the first section. Now I'll just take this particular section over here And wherever you think that there might be a possibility of, see, this is the wall, this is the parapet wall with the layer of plaster or the finishing material wrapped to it. So this particular staircase will join with the unfinished face. So we need to get rid of the overlapping volumes over here. But this belongs to the stair category and it is a structural element. So the base slab, it has been created by monolithic staircase by hosting that base slab. So this won't join with the wrapping layers of wall. In order to get rid of the overlapping volumes, what we need to do is that we need to properly constrain it across this point, that is reference plane and wireframe, and I'll just click this and copy it from here to here. Move this reference plane 0.5 inch and move this 0.5 inch either. Sorry, 0.5 inch. Now I'll just select this particular staircase, edit steps, and select this. And you see this drag handles, I'll just snap it to this reference planes. And once that's done, uh-uh, yes, once and done, I'll just finish and get rid of this reference plane. Now, if you just go to this section, then you see that you don't have any overlapping volumes. Fine, so let's proceed further. Now I'll just click this particular point and let's check here. I need to get rid of this because this stacks a lot. So I hide in view by category and just expand this a bit. Okay, here everything is proper and we don't have any issues. CC, yeah, we don't have any issues. That's fine. This is the plinth floor entrance deck, and this is the plinth level PCC slab. Yeah, that's fine. Okay. Here we have a little bit of glitch wherein this ramp should be actually land up here. But in order to do that, we need to do that computation which I just explained you. You can do it. You can do the needful. Right now, just to save time, we will proceed further. I will now go to this particular junction, and at each and every point, you have to do this. HL. Let me just scale this down a bit. 3/16 of an inch. Oh, sorry, 3/16 is 2/3/8 of an inch. Yeah, fine. So you see that now this parapet wall is overlapping with this particular thing. So I will just say that join this to this, and yeah, that's fine. Why is this PCC slab? Yeah, fine. I need to change this to fine so we can see the associated layers. See, this is not joined. This is the beam wall that we added to that particular beam in order to hide this. So now we need to join this. So select that particular concrete rectangular beam, that wall, and now it's joined. Okay. So this ways you need to cut the overlapping volumes at all the junctions. We did this, but I don't know that why is this, and switch order, switch this to this. Yeah, fine. Likewise here, it's done. Okay, let's move further. We'll come to the staircase. Again, join, select this particular, watch this point, structural framing, and join with this beam wall. And this cannot be joined because it is of structural category, this staircase, that's fine. Just ignore it for right now. Okay, and this junction also we need to join. Join column with this wall. Okay, and this won't join. Plinth level, and I will just take this here. This is also a point because of this curvature, but that's not an issue. Okay, yes, this is the grass floor plate. which was needed to be joined, plinth level. And I'll just take this section over here. Things will simplify once we do a couple of joins. But to reach that stage, first we need to thoroughly go through the all the junctions, join, and the major is that particular beam wall, and also this. And yes, here too. Okay. I don't know how to merge this and get rid of this. This will not join with this, but we'll show in class detection over here. That's okay, fine. We'll check it later. Fine. So you see, I said that things will simplify once you get done with couple of elements. Okay. This should actually merge with this drawing, this to this, but that will Yeah, okay. Section 2, which is this portion? It's not highlighting in 3D. Okay, fine. Let's proceed. If there is a problem, we will check it later. Right now, it seems perfect. See, here it should be. See, I told you something is the problem. R enter, and here we forgot to assign that beam wall. Okay, so see, here also this is not joined. So join this to this, and CS, and pick. And with this core face exterior, pick this surface and flip the direction, and then just join it. Okay, so it's done. Perfect. So within this section, now you see that let's join. It was not still joined. Okay, and join this to this as well. Okay, see, this was remaining. Now in 3D, if you see, it is perfect. Okay, and also here, if there is no wall, then this particular flooring here also and here also with, let me just do the needful. CC, select this particular floor plate, edit boundary, and if there is no wall, then this should actually till be till this point. TR and join this to this and finish. Don't attach and edit boundary lines and TR join this to this and join this to this and don't attach and perfect. Yes. So now let's proceed further. Plinth level and HL. Take this particular section over here. Just watch it. I need to hide this grid lines by category. And wherever you see the problem, just look into the problem and solve it. Okay, everything is perfect. No issues. Yeah, here it is. That done. And this to this. Let me just turn on the thin lines or else you guys will not follow. I'm used to this, doing since 2 years. There's a lot of projects done. So I will not face that problem, but you guys will. So let me just do it precisely. Yes, perfect. And except for some cases where it will be missed, we are just looking forward to solve all the problems. And this hard work is worth it. With this, you'll be perfectly able to schedule it and quantify it. And you can get the proper costing of the 3D element. Fine. So join and join this to this. Wherever you see the overlapping volumes, just join it. See, join and join. Okay, Plinth and this post. Fine. If you cannot work with this precision, then there is no point working and using Revit. This you have to do it. Then only the purpose is fulfilled. Okay, clear. With that, now, if I just check, then you see that, you see, absolutely perfect. All the edges, CC. And here, there was a problem wherein you see that this walls were getting inserted inside. This wall is also getting inserted inside. We will look to that just in a while. But before that, let me just check whether there is no problem. So plinth level, and let me just see this section. And did we solve it? Yes, and this cannot be joined because it is of different disciplines. But apart from that, I guess that we don't see any error. Let me just change this graphic display option and realistic in the intensity of lighting and shadow and sun apply. Sorry, sun should be 100% for the proper visual appearance. So we can see that. See, this is not yet joined. So we missed this particular portion out. Yes. So join and join this to this and switch order because this is the load bearing wall and join this to this. Switch order. The walls should continuously go. And the same falls true for this horizontal sections also, wherein you just need to say that switch order. Sorry, not that. This was column. You're talking about this, yes. So join and switch order. First, you need to join this to this and this to this. Sorry. Okay, and once done, just switch order. Okay, perfect. It seems that everything is perfect so far, but we need to cross-check it that we were talking about LOD 400. That means that the quantification and the costing of each of the 3D elements and the joint conditions should be absolutely perfect. But there is always something which has been missed out. So for that, we do the class detection, which is done here itself in Revit also. Okay. So now we are going to run a class detection test for this much portion only for few elements. And I'll just show you the fundamentals and basics of it and how to clear that thing, how to clear the report and have the perfect model without any error. So here in under this collaborate, you have this interference check. So interference check and run interference check, of which you have this various categories enlisted over here between which you can have the clash detection. For example, for right now, we'll just say that floors and walls. So in your entire project, wherever your floor is getting clashed with the walls, it will generate the clash detection of that. And you see that with that, all that vertical and horizontal section, that intermediate distance we did, and we clarified all the errors, but still some part has been missed out. So these are that. So if I just click that and I'll just turn to CC. So you see that this is that portion. And I told you while modeling also that this wall has inserted inside while we were trying to host a beam wall onto this particular area, that particular wall has joined with this parapet wall. Okay, so we need to resolve all this issue. So how to do that? So herein you can see that this particular wall has inserted inside. If I just go to plinth level and you'll not be able to see it in plinth level, let's go to road ground level and select that particular wall and say that show. So this is the point that inserted inside. So herein, what we need to do, either we need to pull this outside and pull this back here. And again, when we try to join this, then you see that the problem has been solved. And now, if I'll just go to collaborate and say that last report, and this was that particular same. If I just say that refresh, I will just say that refresh. Uh-uh. Interference check, show last report, and say that refresh. So this is, yeah, so that particular error has been rectified. And now it is showing us some another different errors, or is it showing the same error? Show, yeah, fine. So see, that particular error has been sorted out and solved. Okay, now this is another error, R enter, and let's see what is it. Yeah, fine. So see, the beam has not joined with the slab. So modify and join. This we can do here itself in 3D, and it has been joined. And if I just now refresh, that is also eliminated. And likewise, you have to select each of these walls and each of the errors and go to that particular element and rectify the error. This is some tiresome job and hectic job, but it is worth it because with that you will get the perfect schedule and quantification of the elements. Now see, this is getting clashed with the slab. So where is the slab? It is, let's say that HH. Let me just select this and it is getting somewhere clashed with the slab. HH, yeah, here it is. See, it is visible in 3D itself. So I will do that join and select that thing and click this. And with that, that error has been rectified to this particular field. If I just refresh, that is gone. Again, this same issue, and that is also getting clashed with the slab only, but where? So in order to see that, yeah, see here, here it is. So join and this to this and this to this. And with that, collaborate and show last report, refresh. Only one error is left. Where is the wall? Yeah, this is the wall. Okay, so just do the needful. Again, hide this Plinth level PCC. No, it is the same slab. So modify join and join this to this. Okay, and with that, if I just go to collaborate and interference check, show last report, refresh, we are perfectly done and we have our model absolutely perfect as far as the floor and walls are concerned. But there are also other 3D elements which we need to check. And for example, if if I just show you the structural columns is to walls, structural columns is to walls, and if I just say that, or let's say that structural columns is to floors, and okay, so it will create that report wherein you see that this floor, where is it show, and here it is. So again, need to go to 3D, and this is the clash between the concrete rectangular column and the structural column and the finish plinth area. So where it is supposed to be show, and why is it not showing in 3D? Here it is. So let me just go to 3D, and where is that part? That part is here. Okay, no, sorry. Where is that part? That part is, yeah, it's not showing because that thing has been hidden. That was hidden. So that's right. See, if I select this, then you see this particular finished flooring is getting inserted in the structural column. So that will not quantify the floor properly. So what we need to do, modify, join this to this, sorry. Also, let's do that same for this is done and this is now done. Okay. Is there anywhere, is there a chance anywhere somewhere else where we can find it? Yeah, here. So join and join this column with the floor. Okay. And now if I just go to collaborate and show last report and refresh, so many errors have been eliminated, but still some remains wherein, yeah, see, so modify and join. This columns are extruding out and we drew the entire floor plate. So we need to eliminate this, refresh and see, gone. Structural column, this is also there. So join and this to this. Refresh. And now what remains is this walls with the floor, walls with the column, sorry, walls with the column. So this is the wall and it has some problem wherein collaborate, last report, this is the column and it has the problem with this. This is the wall which has the column with this particular problem. Sorry, it is the wall which has the problem with this particular structural column. So what it should be, HH and what it could be. So in order to see that, we need to go to plinth level and go to that particular designated point. And here, this is that particular point. And if we just go to that particular section, then you will realize that what is the error, but still we cannot figure it out. See, this is the wall and this is the column, but they are not even joined. So what is the clash? Here, you need to take that in order to see the clash. But still, yes. See, this wall is getting inserted in the column. So what we need to do, modify and join this to this and refresh. So that is also eliminated. Now only what remains is this wall. Again with this column, show last report. Where is this wall? Show. It is this wall. Okay. And that is getting clashed with this column. So just close it, R enter, H, and let me just check where is it getting clash. Where is the clash? H. I don't see the clash actually. So what is the problem? Mm, can't figure it out. So let's go to 3D and see both the sections, the horizontals and verticals. Then we'll be able to figure out. Yes. So see, that particular wall has not joined with that column at that point. So modify, join, join, select that particular column, press tab, structural column, and that beam wall, which we drew later. So that was one point that was remaining. And with this now, if I go to collaborate and interference check, so last report and refresh, see, this is LOD 400. Okay, level of detail that you provide. Perfect joint condition for all the 3D elements of different disciplines. Their joint condition and perfect quantification and costing you will get with this for all 3D elements. This is how you have to work with Revit at each and every stage. Now, once this shown, we will now proceed on with the modeling part. And mostly I will keep a check off that I don't end up neglecting the clashes wherever it is possible. I will just look at, have a check that we do the perfect modeling. But if not, then once you complete this model on your workstation, just at each and every stage, for example, now we will build the walls. After building the walls, when we reach up to this level, you need to again perform the same check and do the same, generate the same reports and rectify all the necessary and needed changes that you want to do within your 3D model. But that is not possible for this particular tutorials because with that we'll not be able to complete that tutorial. Fine. So now we will proceed on with the further modeling part of this particular project. We will start building the walls of this project. So for that purpose, the first step that would follow is to click this bulb and turn on the AutoCAD plan, which we will take for reference for further modeling. And I will just say that unhide in view by elements and just check its location in plan that is at ground floor level, at plinth level. Yeah, fine, that's perfect. Okay. And why this particular beam didn't continue till here? Because we pasted it from the level below, IC, that is isolate category. And oh, sorry. So by mistake, at that particular level only, if I will just select all of this particular beams and just press H, and what you see that I forgot to stretch this particular beam till this point at this level only, that is at road ground level. So I will just go to this particular road ground level, and herein I just say that R enter and just say that H and H. Yeah, fine. So see, you see that I have forgot to take this beam over here. Yeah, that's perfect. And that we need to do the same for the ceiling plan of ground road level, wherein we need to take this beam all the way till this point. And I think that we don't need these beams. There are some extra beams which has been modeled taken to that particular floor, which we don't need. So I will just delete this and just to cross check. I'll just come to this particular project and complete project and HR and unhide everything. And yeah, see, so we don't need this beam, but we do need this. And also we don't need this particular beam to be taken up. Okay, so this is perfect. Fine. So whatever changes we did were perfect. I'll just say that unhide and undo, I mean, and get back to this and keep this on as it is for our reference. So the next step is to elevate the walls onto this particular floor plate. So for that purpose, what I will do is that I'll just go to this particular plinth level floor plan and we can see the plan because it is there on that level itself. Okay, see, this is that AutoCAD floor plan. Okay, so now we have to start with the modeling part of that walls. So I will just click this particular walls and the walls already exist. Main wall 9 inch. And if I just go to edit type of that, and if I just go to edit, then you see that it is this wall paint, the core structure. This is the material, wherein if I just take it to this particular material, then this is nothing but just the uh, yes. So wall paint has been given the color. Okay, this is the color that has been given to it. And this is the cut pattern, which seems like it is a brick hatch. You can also load your AutoCAD hatch if needed. But right now, we will just proceed on and plaster. I just go to plaster, plaster. Yes. And plaster has been also applied the same color, but under the graphics pattern, I'll say that none because that is just a small sliver wherein we don't need to show the cut pattern. Okay. And together with plaster thickness, it makes it 10 inch. Okay, now the modeling of this walls is very important. Wherein, if you think that if this is the cube, and if I just take this rectangular and model those walls from here to here, then that is incorrect method, which I just said in my introduction, because that will not quantify the walls properly. Because if you want to take out the material, if you want the masonry, cost of masonry, number of bricks, and material quantity, everything if we want, then once by snapping this, we will snap it, we will join it with the structural element, but it will calculate all that quantities on the basis of area, that is length by height. So that is untrue. So we need to be very particular while the modeling of the walls, and each of the 3D elements should be snapped exactly across the boundaries where it is supposed to be. It should exactly follow the footprints of the floor plan, AutoCAD floor plan, and it should be snapped to those lines. Okay. So what I'll do is that wall and with plinth level base constraint and base offset 0 up to top constraint should be first floor, but essentially the top offset should be minus 1 foot 6.5 inches. That is 18 inch of beam and 0.5 inch of plaster. Okay, so that would make its unconnected height 8 foot 5.5. So that's perfect. And with that, now I'll just say that core face exterior, and I will start snapping of the walls from this point to this point and wherever needed. Okay, and you cannot see its cut pattern because the detail level was coarse. I'll just turn it to fine. So you can just visualize it. And here there is no column. So we can just draft this L shape walls. And again, I'll just say that CS and draft it to here and draft this particular wall, which here the person who is standing here would have the visual access to this particular courtyard. So herein the base offset would be 0, but the top offset in this case would be just unconnected and just a small sliver of 9 inch. Okay. And again, we will continue from this point with that same constraints, that is the first floor and unconnected at top offset minus 6.5. Okay. And let me just complete it. 1 and 2 and this entire wall from here till no, there is a column, so we need to stop at this point. Again, continue from this point. 1 and 2, and this will stop here. And this, I guess, you need to flip the direction, CS, and again this wall from here to here, and this particular wall. And here we don't have any column because I need to model a corner window, so that's why I purposely not kept it. That is again a structural concern, but I'm just showing you the modeling part. I'm just going to show the modeling part, that how to create a corner window in Revit. Okay, and with that, this would snap to here, and you see that the two wall joins. So when such things happen, what you need to do is that you see that all these three walls join because of the junction. So that is not true. So just go to modify and click this particular wall join and select this and say that disallow join. So with that, when you will click, now you can properly constrain that wall according to your preference and your need. Okay. So with this, okay, perfect. And rest anywhere else, it's not an issue. So with that, we have drafted the walls. I'll just say that WA wall, and we also have this internal wall, 4.5. The only difference between that is that this core core layer, the core structure has been reduced to 4.5 internal wall. Okay, apply and okay, and rest the constraint remains the same, not up till terrace, but up till first floor. Okay, and core face exterior, and just snap it here. And again, this joins. So we'll have to unjoin that, and that's okay. I will just go to wall joint, click this particular junction and say that disallow join, and click, snap it here, and snap this point to this. Okay, and join this to this. The plaster layer, I guess we should join. Okay, and the same is the case here. Join, and the plaster layer should connect. Okay, fine, perfect. So let's just see it in 3D. This walls were supposed to be not up till terrace, but first floor with the negative offset of -6.5. Clear? So that is how we have constructed all the required walls of that particular floor. Clear? Now, what remains is that you see this purposely I have made this particular column orientation be like this, just because I want to see that if we have the extruding faces, most important, this four columns are of different sizes, bigger sizes, and also this beams. This beam is 9 cross 24, but this beam is 12 cross 24. And likewise, this column also 1 cross 18, 1 cross 18. This is 1 foot, 1 foot by 18 inches. But this all the rest, all other regular columns are 9 cross 18, which would be fluffed within the wall. So this was the purpose was to show you guys that if we have extruding and elevating faces within our structure, then how to wrap it with the layer of plaster. In case of wall also, I mean, in case of column also, and in case of beams also. Okay, so the first thing is that I'll just go to the plinth level, and herein I will just come to this architecture, and here, apart from all the structural columns we loaded while going to this category structure and column, so that is CL, that would load the structural column. But apart from that, under the architecture tab, we have this architectural column. What is the purpose of this architectural column? Adds architectural column to building model. So if I just select this, and you see that if I just place it anywhere, then that will occupy the place in the wall, and it will follow the geometry. Okay. So the purpose of this particular wall is just to wrap with the existing wall if there are extruding faces or the thicknesses. So that is the purpose of this architectural columns. Okay. So I will just go to this column architecture, and with that I have already the size defined. 18 cross 18. What is the size of this? It's 9 cross 24, and this is 1 cross 18. So we have to design a column architectural which would, why was this family not copied? Anyways, let's not waste time, and I will just go to this 18 cross 18, and I'll just duplicate this, calling it 12 cross 18. Okay, that type is not defined, and herein I will just say that change the depth to 1 foot. Okay, but we need to exclude the plaster layer. So rename, and this layer of column is just going to wrap the layer of plaster to that structural column. So it should be zero point 0.5 inches more on both the sides. So that would make the size 13 cross 19. I just make, you will just understand once I host it. So depth should be 13 inches and this should be 1 feet 7 inches, that is 19 inches. Apply and OK. And with that, now you see that height up to first floor. And if I just flip the direction and place it, you'll see that it will wrap with that structural column in a such a way that only the layer of plaster. But for that purpose, we need to join. Right now, I'm just hosting that thing. And once hosted, we will do the required changes, that we will just go to 3D and hearing. You see that now the concrete layer is not visible. If I just click H, then you see that because of extruding faces, the concrete column was visible. Okay, but with that architectural column, with that size wrapped onto this, now you have the flushed surfaces. But essentially, what we need to do is that we just need the layer of plaster within that area, within that portion, within that column. So I'll just go to modify and join and select this structural column. Watch this point. Select structural column and the architectural column. Okay. And also within this beam, uh, it didn't join or what? Structural column with architectural column. Mm-mm. Join and select the structural column and then select the architectural column. That's perfect. Also, we need to get rid of the plaster layer for this faces. So just join and join. And this thing, you have to do it in 3D. Okay. And likewise, we will do the needful for the same process for all these different columns. That is join and press tab until you find that architectural column. Sorry, structural column. It should read structural column. Watch this point and join with the architectural column. Yes. There you need to be very careful. Okay. And this to this, this to this, and likewise this to this to this, and get rid of the plaster layer, overlapping volumes, and enter join, and yeah, it's already done. No, we need to, but for that, this beam should be HH. And this beam is up till here. Yeah, fine. So what is the issue? Let me just go to ceiling plan of plinth level, and with that column, yeah, it's snapped till here. Then what is the issue? Why is it not joining? Join and join this to this. Mm, here it's done. See, if I just select this and HH, the plaster layer has eliminated from that particular area. But here it is creating a problem. When such thing happens, just select this and delete this beam. Okay, and just go to the ceiling plan of plinth level and HL, hidden line. So I added the shortcut. Turn this graphics to fine. Okay, and just change this particular view range from 7 feet to 9 feet. So we can see the beam. Okay, and with this beam selected, just say that CS and pick a plane, and that should be first floor. Okay, and with that, the top of that should be laid on that particular first floor. That's perfect. And this justification to right, I will just snap it from this place to this place, and it will create proper justification. Sorry, CS and why is that justification? Why justification to right? That's perfect. Then why is it okay? This is the line, I guess, which I need to snap to. This is trial and error left. And with this, I will just snap it from this point to this point. Okay. And again, it's creating a problem. Let's change this to right. Okay. And with that, I'll just go to 3D. And with that laid, if I'll join, this should eliminate the layer of plaster and it's perfect. Also, we need to get rid of from here. But before that, we need to join this first. So press tab until it selects the column and then this beam and this beam and this. Okay. So I showed you how to get rid of, how to wrap the layer of plaster for this extruding columns. Fine. Extruding and projecting columns. I've shown you. Now the beams is less, but before that, I guess that the two columns are still left and that are the regular sizes, but the orientation is different. So again, I'll just go to this plinth level and say that architecture and column architecture. And we will now have to duplicate this and this size will be 10 cross 19 because the structural column is 9 cross 18. So this would be 10 cross 19 and apply and OK. And you see that perfect. Height up till first floor. And what is the problem? Yes. So you need to be particular when you snap. Just make sure that you are snapping to the perfect. Okay. And now if you just go to 3D, then you see that the layer of plaster has been wrapped to those two projecting columns also, with which have the size same but the orientation is different. So the same process, join and just select the structural column and join it to architectural, tab and yes, tab, tab and just join. Yes, yes, it should select that. Then this beam, again, this beam is CCR enter. Yes, this beam should also select this and join this to this. Yeah, fine. So see, the layer of plaster has been eliminated. And you see that this particular layer of plaster will merge with the layer of plaster that has been applied on the wall. Okay, and likewise join this to this and get rid of plaster from here and also from this end. Fine. So this is the modeling part. Okay, perfection in modeling. Now with this, what you need to do is that what you see is that all of the exposed surfaces of beams and one column remains. There is always one thing which remains. And this has joined to this particular, which shouldn't. So I just go to modify. This is joined or not, but it got connected with that particular wall. So what we just need to do, we need to drag this to this point, this to here. And that was not the layer of plaster. That was the wall which got flushed to those structural columns. And now what we need to do is that we need to wrap the layer of plaster to all this smaller columns also, the columns of smaller size. Okay, so just see that CS and just do the needful. And in this case, it is not snapping because it couldn't find the snap point. We'll do that later. First, let's get done with all this. Yes, and this. Okay, this too here, and it automatically snaps and connect. This is one column outside. This Okay, and rest, everything is done. Only this is the problem. So doesn't matter. I'll just place it somewhere over here. Sorry. I'll just turn it to wireframe and just align it this face to this face, this face to this face. Herein, I will just move it zero point 0.5 inch. And here too, I will just move zero point 0.5 inch. Okay, that's done. HL, that is hidden line. Okay. And here, there was some problem. Yeah, here. This is not same face. I guess there is a problem with the, I'll just say that delete. This wall has not been properly placed. Move and move it to this. Yeah, fine. So with this now, if I just say that architecture and column architecture and place this, it will properly get flushed within that. Okay, now go to 3D and just like we did for all the, for these two columns, we need to do it for all the columns, but there are a lot of elements. So what we'll do, just select this rectangular column and select any of the, watch this point, it should select this architectural structural column. Okay, and just say that IC. That will isolate the category. Now modeling becomes easy. So now you can say that modify, join this to this, and join all the required, but in this case, it has flipped. It is very important that what you select first, press tab and structure should be first. Press tab, structure, cancel, and modify and join and multiple join uncheck. If you are using a version of Revit lower than 2025, then this option of multiple join will pop up somewhere here. So just make sure structure with architecture, and then again tab structure with architecture, structure with architecture, structure with architecture. You need to press tab a couple of times in order to make that structural column select first. And this is joined. This two, both of this are joined. What left is this structure with architecture. Yeah, that's done. Okay, and why is that I couldn't find that here? I forgot. So say that CS and do the needful. Go come to 3D and join structure or join and press tab and structure with architecture. That's fine. Perfect. Okay. So yes, absolutely perfect. You see that here there is a beam. So the plaster layer with that joint face, the plaster layer has been eliminated. So this will properly quantify, perfectly quantify it. Okay. And is any column left? No, none of them. Everything is perfectly joined. Clear. And I'll just save it before I lose it. Now, within this beams, we need to get rid of this architectural columns. So I will just select this architectural column and this beam and say that IC, isolate category. So I can just get rid of the plaster layer from that with that faces. Join and join. Okay. This is very important. If you don't perform this steps, then you will not be able to quantify or schedule it properly. Join and this to this. You see it is eliminating the plaster for common faces wherever needed. Okay. This is the perfect modeling for which Revit is meant for. CC, join, and yes. You can do this in section also, but I'm used to doing it in 3D, so that's why if you are not comfortable, sorry, if you're not comfortable in 3D directly, I think 3D is much more easy than working in section. Yes. So with that, we have joined everything, all the structural elements. Well, now what we need to do is that wrap the layer of plaster onto this exposed beam surfaces. So how will we do that? Because just like architectural column, we don't have a structural beam, architectural beam. We don't have that. So what is the way out? So the way out is that just go to the ceiling plan of plinth level, and herein just click wall, and for that particular plinth wall, just create a beam wall. And I've already created one. We laid the beam wall on the beams which are on that particular ground floor, which has the plaster layer only on one side. But now for this particular beam wall, we need beam external plaster 1 feet, which has plaster on both the sides. Okay, clear? And the constraint would be 8.8 what? Yeah, 8.5 and a half, 5.5, 8 foot. Sorry, this would be up till first floor with the top offset of 0, but this would be 8 foot 5.5 inch. Okay, and this will be the beam wall which we need to create. Again, for this particular 1 and 2, 4 walls, that the beam is the of the larger depth. So this will come only here, and you see the perfection in modeling. And likewise, if I just take this particular beam up till this point, then it will wrap. Okay. So this particular 4 beams are done. Now what we need to do? We will do it for this particular smaller beams. Okay. So just say that wall and wall beam external plaster 9 inch. Edit it, and you see that it has plaster on both the sides. That's fine. Perfect. And just this will also, from this point, we will just connect this, and you see that this, because this is the same material, so it will flush and it will not read double quantities. But what you will need to do is that after creating this particular beam walls, you will need it to join it with the beams, structural beams. Okay. And here also there will be press space and yes, little bit of glitch, delete, and just say that wall, and that same wall. And here is the problem within that particular column. So that's why wherein the layer of plaster is not properly, but this is proper, I guess. Why is it showing this? This is half inch, and this is also no, this is not half inch. So I guess that little bit of glitch. Okay, with this, okay, perfect. And this, just select this CS, and from this end to this end, and wrap the layer of plaster to all the beams. And complete the modeling process. Yes, this entirely goes till this point because there is no column, and this will join with this. Again, CS, and you can also pick lines. Pick lines would be easy, but the selection should be very particular. Yes, no. Core face exterior, and just create, and this would be much easy. What you just need to do is flip the direction. Flip and flip for all the created once. That will save a bit of time. And CS, pick, oh, not that CS, this beam wall, rectangular beam. Yes, beam wall, plaster 9-inch CS and pick and snap it. It is somehow not snapping. Yeah, see, in this case, it snapped. So here, if it is not snapping, doesn't matter. Wherever it doesn't, just flip, select and space, select and space. Fine. So with this, now what you need to do, you need to go to 3D and just select any of the structural beam, press tab, structural framing, and this beam wall, and just HI. Sorry, structural framing, press tab, watch this point, press tab and select the structural framing, and then the beam wall, and say that IC, that is isolate category. But since the wall has been created, those the beam wall belongs to the wall category, so this will isolate all the other walls also. But that's okay. What you just need to do, you need to pay attention and do it carefully. There is no other way out. So I'll just say that join, select this structural framing, and just do the needful quickly. Okay. And in case of beams, it is doing faster. That's good. Join. Okay. And yes, this beam is of the height what? This is top offset minus 6.5, and this beam is 9 cross 24. Mm, so I guess that there is some mistake within this this beams. All these beams are how much? Angular beams 924. So with that, the constraint has changed. 924 कैसे हो गए? Oh yes. Okay. The reason I got it. We copied it from, we selected all the beams from this level, that is the ground level, which were the inverted beams, which was acting as the plinth and ground beam both. We copied them to clipboard and pasted it at this level. But actually, all the beams at this level would be of the lesser size. The depth of that these beams of this structural framing would only be 18 inches. So I will just do SA, and from this, Revit is there, so you don't need to worry. Just deselect all these beams. And with all these beams selected, just change it to 9 cross 18. Edit and see 9 cross 18. Yeah, that's fine. So with that, now it will perfectly wrap. Okay. And join and just select this framing to this. Okay. This is left. Okay. And here there is a column, but this beam structural framing with the wall. Yeah, fine. Just like that, structural framing with the wall. Okay. And here there is a column from which I need to get rid of this plaster layer. Yeah, that's see, perfect. Okay. And likewise, we need to join this bigger sizes also. This is not perfectly joining. Yeah. Okay. And so the first time I'm performing the steps in 3D itself. Otherwise, I usually for other tutorials, what I used to do is that I used to do it in sections. But this time I'm well used to it, so I can do it. Okay. And yes, perfect, absolutely perfect. Something always remains somewhere. So where is that somewhere which is left over within this? You need to get rid of this. Okay. And this should join here, plinth level, and oh sorry, this should come till here. Yes, fine, perfect. Yes. As I said, this remains. I forgot to snap there. Select that CS and just pick lines and select this. Okay. And just flip the direction. Okay. And just go to 3D. And herein, I'll just say that join. Select this beam and okay. Okay. So with that, now we are perfectly done. You see that how beautiful. This is the beam wall. This is the beam. And here there is a floor plate and only the layer of plaster with this particular wall, ground beam wall, external wall 9 inch, which has plaster only on one side, one face. Okay. And HR. So you see that now it is absolutely perfect. Why is this CCR enter? Yes, also this four beams, one, two, three, and four, which has been copied from that lower level. I need to change it to 18 cross 24. I mean 12 cross 24, not 24, but that will change there also. So I will just go to edit type and duplicate this and call it 12 cross 18. Okay, and this I'll just change it to 18. Apply and okay. Fine. Yes, but why is it showing the beam wall external plaster edit? And yes, so this is not me applied the material, so that's why it is showing a different material. Let me just go to here and this also has not been applied the material. That's strange. Let me select any of the wall, copy, edit, and this one plaster, copy, apply, and OK. And select this external and just select this plaster and this to one wall paint, which is going to be excluded. So it doesn't matter. Apply and OK. So one homogeneous material. And for this rectangular beams, I will just go to edit type, and those should be one plaster. Apply and OK. Even for this rectangular columns of smaller size, one plaster, apply and OK. Let me check within this. Yeah, okay, perfect. Absolutely perfect. No issues up till now so far. Edit and yeah, fine. So this is how, with this precision and this perfection, you have to model 3D elements in Revit. Let's proceed further, completing the column beam framework for this particular floor, first floor. And I'll just select this particular ground floor AutoCAD plan and hide in view by elements because we don't need that particular plan now. And also let's rectify some glitches within this. For example, this will follow and just press and just say that I'll just hide this and select this particular beam and IC, the shortcut that is from here also you can do isolate category. So that category is isolated, and within this, I'll just go to modify and split. I'll split this element, this beam, join this to this, and join this to this. Okay, and I will just get rid of this particular beam. And herein, I need to add this three members. So I'll just say that copy to clipboard and very powerful function, paste, align to selected level and to first floor. So that will copy, but the only point is that we need to properly position it and first floor, and the top of that should be laid on first floor. So that will bring it in place. Okay. And with that, I'll just say that HR. Okay. And also let's get rid of this. But before that, I'll just say that CS, create similar pick, and one, two, and three. For this, I'll just press space, and this also I'll just press space. With this, I'll just delete this, and I'll just say that join, select that beam, join, and join. And also this, I need to get rid of the plaster over here. Okay. And also this, I need to join. Okay. Perfect. Fine. And within this also, I guess that, yes. Okay. Clear. Now, what next is that here also there will be one beam at this level, and here also there will be one beam, which I guess that I forgot to extend here in this floor plate also, ground floor plate also. So for that purpose, I'll just go to this plinth level plan, floor plan, and first hmm, first let's load the AutoCAD plan. Yeah, AutoCAD plan is there already, but here there will be one beam, I guess. Let's go to that particular project for reference, and let me just check the ceiling plan of ground floor. Yeah, see, there is a beam over here. Okay, so which I forgot to snap for that particular. Okay, so what I will do, we will just go to ground floor, ground road level ceiling plan, and yes, herein I will just change this particular view range to 2 feet. With that, we'll be able to see the beam network, and I just hide AutoCAD plan, hide in view by elements. Don't need it. Change the scale, lower down the scale a bit. Okay, so here there will be one beam, but why is that I cannot see the other beams? Ceiling plan of road level, and it should actually show the yeah. See, this needs to be changed to fine in order to see the beam, but still we cannot see the beams. View range, and let me just change this to 3 foot. There should be the beam network should be visible. Let's try 3 foot 9 inches. No, let's uh, let's change this cut plane to 1 feet. Yeah, okay. So with that, you see that all the beams are visible, and I just select this particular concrete rectangular beam 9 cross 24 and CS, and I will just snap it from this point here and just align it with this face. Okay, and just flush it. So where did it create? Let's just check. Yeah, it created a perfect place. No issues. And what we will do is that we will just say that copy to clipboard and align to selected levels, and let's say to first floor, I guess. Yeah. And for that, I will just select this particular beam and change it to 9 cross 18, smaller size. And the top of that should be laid on that particular level. And yes, so with that, everything is perfect now. What we just need is that join, get rid of overlapping volumes, and snap the beam wall, CS, and pick and select this. Just press or 2 times I created. Select this and press space and join this with this. Okay. So with that, the framework is complete for that particular level, beam column grid. Now we will need to add a couple of more beams for extended balconies on that particular floor. But for that purpose, what we need to do is that we need to go to the first floor. Okay. And herein, I will just say that I select category. I didn't, sorry, hide by category. And herein, I'll just take one reference point wherein we can snap the AutoCAD plan for that particular level. But before that, I'll just go to Insert and Import CAD and navigate to that particular location, PTS and Live Classes, Basics, and First Floor. Auto detect this import unit should be inch, since this particular AutoCAD plan is in feet inches, and this should be manual center, and just open. And where is the common point? VG, and I'll just say that import categories, turn this first floor to halftone, and this is, I guess, the common point where we can snap. So LI, and I will just select this, or what else? Wireframe. I'll just turn this to wireframe so we can see the AutoCAD plan of this as well. Yeah, LI, and I'll snap this point. Okay, or let's just delete that, modify and align this to this and this with this. That is how we have placed the AutoCAD plan for that particular designated floor. And now with this, I will just say that underlay should be none. Okay. So with that, now you see that the beam column framework, the beam network grows like that. Here we need to add this extra beam for that particular designated floor. And the underlay is right now none. So that's why we cannot see anything. If you want to see anything, then just change this to Plinth level. Okay. And the AutoCAD plan I need to hide. So how is that? Can I do that? Mm, for that particular floor? Actually, I guess that we don't need to with this underlay option. I guess that we cannot hide the AutoCAD plan or any elements. So I will just say that none, because we don't anyways don't need it. But what I'll do is that now we will work on this particular floor on this AutoCAD plan wherein I need to create this particular beam network. So I will just say that structure and beam and 9 cross 24, that's 9 cross 18. And I will just say that the top of that should be laid, no, not top, but the bottom of that should be laid on this particular level so that we can see that what we are drafting. And I'll just say that pick lines 1, 2, and 3, CS, pick lines 1 and 2. And I will just select all of this SA on that particular level and Z justification to, not Z justification, Y justification to, let's say left. It is left only. So I change it to right. No. Okay. So we have to do that individually. And so right, sorry, right. Yes. And this to right as well. But it's not working that way. So I'll just delete this element. Right. Yeah. Fine. And this to right as well. Okay. And I'll just change this here. Snap this here. But yes, because of hmm, let's say that CS and pick lines, and with this to right, let me just click OK. Yeah, and yeah, fine. So let's see it in 3D. Yeah, okay. Now, since we have snapped this beam for that balcony on that particular level, now I'll just select all these beams and just change its Z justification to top, saying that the top of that should be laid on that particular level. And this is creating a problem. See that bottom, it's not changing. Top, I don't know what is the issue. Let's say that the justification will be minus 18 inches. And two, it's not. I'll just say that delete, go to first floor again and say that beam, pick lines, and the top of that should be laid on that particular level. And I just click this and not visible, that's fine. And go to 3D, yeah, fine. So it is perfectly now placed at the designated place. Clear? And now what I will do is that I will snap the external walls, the beam wall external plaster to those newly created beams. And just finish. Okay. And this, I guess that I need to press space, modify and join structure to the beam wall and the structure to the beam wall. Fine. And here I guess, yes. So join and join this as well to get rid of the overlapping volumes. Fine. So that is how we have added this profile as per this particular first floor plan. Okay. And rest everything, I guess that, yes, here also there is a change. Here there is a change at particular this level. So let's just go to, and yes. So see, here there is the beams are right angle joining at 90 degree, but this particular beam, as per the AutoCAD plan, is little bit inside also and having this curve. Yes, fine. So let's just do that same thing here as well. So I will just get rid of this, delete and delete this as well. And this and go to first floor, but you cannot see it. Where will you be able to see it? Ceiling plan, ter not terrace floor, ceiling plan of Plinth level. Okay, yes. So see, we can see the beam network, but we cannot see the AutoCAD plan. So what to be done in this case? Wow, okay, fine. Let's draft the, let me just take this a bit inside and then I will just go to first floor and let's draft that particular here. So architecture and beam, and I'll just say that pick, and let's say that the top of that, oh no, but again with that this curve will not be seen. So why justification to no, but in order to see the placement, we need to see that elements once placed. So I'll say that bottom and yes, and just change it to left. Okay, and with this, I will just say that the top of that should be placed. Yes, and it's gone at its designated point. Perfect. Okay. So with this now, what you can do is go to Plinth level and take this particular beam inside and snap it to the required location. Yeah, see, perfect. And okay, select this CS and pick this unjoin shift. Okay, press space again CS pick and press space. Okay, and revert the direction. And now just going come here, modify and join this to this, this to this. Okay, absolutely perfect. No issues. With this, this, I guess that right. Yeah, okay. So with this, now we can HR and where is this flow plate? CCR enter. Yeah. Okay. So with this, now what we need to do is that we need to create the floor plate of that particular first floor, different areas of that particular first floor plate, wherein for these two washrooms, we will have the drop slab. Okay. And also this balcony and this terrace will have the drop slab since they will be affected by external rainfall. We didn't create that for this particular ground floor because herein this particular floor plate is resting on ground. So we don't need to provide the brick back layer and waterproofing layer and drop slab. But here at first floor, we need to do that. And if I just go to 3D, then what you notice that once I place this particular floor plan, so I realize that here also there will be a beam and here also there will be one beam, tie beams, connecting beams. Okay. So we need to place that particular thing, and I'll just place it in first floor itself. I'll just go to structure, beam, and for now, I'll just say that 9 cross 18, and the bottom of that should be laid on that particular floor plate so we can see what we are drafting. And I'll just connect this to this, and hearing from this edge, I'll just connect this. But for this, I'll just change this to left. Okay, fine, perfect. And this will stop here, but it's getting inserted inside, that's fine. I'll just go to 3D. Okay, and I will just say that both of these beams will have the jet justification to top. Okay, and no issues. Let me just temporarily hide the AutoCAD plan, and I cannot select wireframe and just select this AutoCAD plan and hide it temporarily. R enter. Okay, and what we need to do, we need to say flush this beam wall CS, that is create similar pick line, host 1 and 2 and 3, press space and invert the direction, modify and join this to this, this to this. Okay, and also this beams need to get rid of the plasters from this. Okay, perfect. Fine. So this would be the grid, column beam grid at that particular level. And now with AutoCAD plan HR, I'll just go to first floor and we need to create the RCC slab. So structure and architecture and floor structure. And I will just select this first floor RCC, typical thickness 6 inch, the slab, concrete slab. And I'll just select this boundary lines and just draft it. Okay, and LI from this point to this particular point, LI, and from here, and just follow the footprints of the plan. TR, join this to this, and this should connect here. Break the lines and just create this. Okay, and with this slab, RCC slab created, I guess that this should follow the exterior surface. Yeah, fine. Okay, and here, what could be this? Okay, that's fine. That's perfectly fine. No issues. Yeah, and just finish and say that don't attach and just get rid of this particular symbol. Hide in view by elements. Go to 3D. Okay, fine. So now we need to join here and this AutoCAD plan. I guess that we don't need it in this view. Hide in view by elements. HR. Oh, sorry. R enter. Okay, and what we need to do, we need to say that this and this floor and say that IC isolate category. So we can just get rid of the overlapping volume, modify and join, get rid of the plaster layers, join, and with multiple join, 1, and 2, 3, and likewise do for all the spaces wherever needed. And that is how we are deducting the wrapped plaster layers to beam from that slab. CC and R enter. Okay, so that is how we have created this particular slab HR. Yes, and something always remains. Okay, so for here we need to say that this particular floor plate edit and HL, this should actually be this. Yeah, so get rid of this line, delete TR, and join this to this. Okay, and just finish. Don't attach. Yes, and CC, join, and just join, and wherever the leftovers. Yes. So that is how, sorry, R enter. Yeah. Now the floor plates for this all will be the drop slab. Okay. Conventional, this is the cutout, but herein there will be a drop slab. I'll just go to first floor and again say that CS create similar and rectangle, flush it from here to here and this to this point. Overlapping volumes, I'll just delete it, TR and join this to this, delete, TR and join this to this. Okay, and just say that pick lines 1, 2, 3, 4, 5, LI, connect this to this, and just say that split element TR and join this to this. Okay, all of this will be the drop slab. Also here, boundary line and snap it here. Yeah, fine. Okay, and also this rectangle, snap 1 and 2, delete this line, TR and join to this to this. But the height offset for this particular slab will be -1 foot because it had the thickness of 6 inches. So the drop slab will be 18 inches. So 1 feet down and just finish and don't attach. Let's go to 3D. Yeah, fine. So see, the drop slab has been created. Clear? So that is it. Now we need to create the finishing layers of this particular finished flooring of this particular floor plate. And this was remaining. So let's join this. Okay, fine. CC R enter. Let's see it in CC. Consistent color. So if any glitch is there, then we'll be able to solve that. But here I can see that this rectangular column is not joined with the architectural structural column. So just press tab structure to this. Yeah, CC and R enter. And also join this to this. Okay, let's see it in consistent color. If anything is left out, no, fine, absolutely perfect. Yes, and beams, this particular beams will not have the plaster inside because here there will be a drop slab, but we will join it and get rid of it later. First, let's create that particular join this to this. Yes, and why it is. Yes, here this is the overlapping volumes. The first floor, select this and first floor. Cannot see it because that is the level below. So, okay, let's just ignore that much portion. That's fine. You can go here in 3D itself and just, okay, fine, perfect. Yes. So now we need to create the finished flooring of this particular floor plate, different finished flooring for this particular floor plate. So again, I'll just go to first floor and wireframe and let me hide this particular icon, hide in view by elements. And now let's create different finished flooring for this particular area. Okay. And for this particular level, and I'll just go to architecture and herein I'll drop floor architecture and herein I have already defined since I transferred the project standards from that particular complete project. You see that we will not waste time on creating that floor, but I'll just show you first floor public area, edit type. And if you just go to edit, this is reading ugly fraction. So I will just say that this would be sand bedding PCC. Now, just since this is first floor, so we'll have this layers and wherever needed, the brickbat layers for waterproofing drop slab. But for this, I will just say that sand bedding PCC, that would be 20 mm. Okay, and yeah, 20 mm, and this would be mortar, that is 12 mm, that is 0.5 inch, zero point 0.5 inch, and the first floor public finished flooring, that is 0.75, that is 19 mm tile. Okay, now we need to total this up because this thickness is ugly fraction. So in order to do that, I'll just say that okay, apply and okay. I just go to UN and change this particular unit's length to millimeters, rounding up to two decimal places. Okay and okay. And then I will just go to this first floor public area, and this should be 20, this should be 12, and this should be 19. So that rounds up to 51, 51 mm of finished flooring. Okay. So apply and okay. And I will now just draft it. So the public areas in this case would be this much. Okay. And herein, I need to deduct this area. So snap it to this line, but we couldn't. So just split this line and then pick lines one, two, and pick TR, join this to this, join this to this, and join this to this. Okay. So that would be the floor plate for this particular finished floor public areas, circulation area. Okay. And with that 51 mm height offset from level, because if I'll just say that with zero, if I will just finish, then don't attach, and you see that highlighted floor overlaps. So if I just take it to the particular section, then what you see is that the finished flooring has overlap with the concrete slab which has been casted. So we need to move this up. And what is the total thickness? 51 mm. So 51 mm, and this is the best part that you can switch between units. Okay, so that particular floor, finished floor, has been taken to that particular designated level. Okay, so I just go to that particular first floor, and now CC, we need to create other different floorings. So I will just go to floor, architecture floor, and floor architecture, and just finish floor private area, which would be again the 51 mm, the same construction part, only this finished flooring material is different. Finished floor private. This JPEG image has been applied to it. Okay. And I would just say that HL, and this would be the flooring, which we'll be putting up here, and this relax area, and this bedroom from this part to this part. And also we will say that line and consider this part as well. Split lines, TR, and join this to this and this to this. Okay, so this would be the private areas with the 51 mm of offset and finish. Don't attach. And now if you just see, so this is the first floor public area, and this is first floor private areas. So the flooring differs. I go to R3D, R enter. Yeah, fine, clear. Now is the toughest part, wherein we need to create the drop slabs of this particular uh, two two washroom plates and three terrace and balcony area. Okay, so I'll just go to first floor, and first is that we will create it for this washroom floor plate, and just floor and floor architecture and first floor washroom floor plate. Yes, and if I just go to edit type and edit, so you see that this is the construction part wherein brick beds, so much of layer, sand bedding, and okay, if this conventional is 100 mm, fine. So it rounds up to 144.6. Let's get rid of this 12 mm, 12 and 20, and let's have a round figure. round figure which would say 144 mm. Okay, if the brick beds, the size of the brick beds layer will be decided once we lay that particular flooring in a such a way that there should be one tile drop between the washroom and this particular private areas, bedroom flooring, so that the water won't penetrate inside. But how we will decide that what would be the actual size? So for that purpose, first I will just create one, and herein I will just drop this split lines, join this to this, and join this to this. And likewise, I will create that same here as well. Okay, and L line, and just create this TR and join this to this, and TR and join this to this. Fine. So with this, I will first say that 0, and let's have a flush connection, or let's say what was this 144. So yes, give it a 144 of height offset and just finish and don't attach. Now I'll just take this particular section over here. Fine. So now what you see is that this is the floor plate, the finished flooring which has been laid on that particular this particular drop slab. Okay. We need to deal with all this, but that later part. First is that let's just properly position this. So this should actually be at this level. So I will just say that modify and align this to this. Okay. So the finished flooring of this particular washroom has been flushed to this particular RCC slab, drop slab. Okay. But now this should actually, in a such a way, this should elevate the brickbat layer should be such that there should be only one tile drop between this flooring, this finished flooring, and the finished flooring that we will lay for this particular washroom. So if I just calculate this, then you see that we need to add 211. But if I just say that move this 10 mm, 10 mm down, one tile difference, and you see that 201.80 we need to add in order to have the one tile drop. To be more specific, 12 mm, so 2 mm more. And with that, if I just calculate this, so 199.80. So where will we add that 199.80? We will add it here. So 100 plus 199.80 makes it 299.80. Okay. And with that, if I just say that highlighted floor overlap, that's fine. But now I will just elevate this, or I will just say that align tops of this with this. Okay, so highlighted floor overlaps, that's fine. But you see that there is perfectly one tile drop between this finished flooring and this finished flooring. And there are a lot of joint geometries and problem over here that we will do it later. But right now, let's just first finish. And if I just check this section, then this is also perfect. Okay, wherein we have the one tile drop between these two. And I guess that if I just go to first floor, then yeah, it's perfect. It's perfect. We don't need to continue here because here there will be a wall. Okay, fine. So first floor, and now with this, I will just say that create similar and drop this down to first floor balcony terrace. This is the balcony and this is the terrace, wherein everything remains the same except for this terrace finished flooring is assigned a different material. Okay, this is the China mosaic flooring. The material that JPEG image has been assigned. But again, the same thing, we will just change this to 299.80. Okay. The computation that we did earlier, I'm just following that same. Okay, 20. And that would make it 343.80 and apply and OK and apply. And with that, I will just create over here, then over here, this part, and line, and just I need to flush it properly. Li, create this, and pick lines, And yes, TR, join this to this, join this to this. Okay, a little bit of drafting work. That's fine. Just delete this lines. And for this terrace as well, pick lines one, two, sorry, one, two, TR, join this to this, delete this lines. Okay, and have I snapped perfectly or not? Yes. Okay. Yes, and with that, I'll just say that finish. I say that don't attach, but what needs to be done is that properly position it, wherein right now it is putting up here. I will just say that flush, and you see that perfectly. We have a one tile drop between the finished flooring, public areas, and this in this case, in this section. If I just take this particular section here and see it, then to same. See? Okay, perfect. And we need to join a lot of geometries. That's fine. And this is which area? Balcony. This is the balcony. This is the terrace. Okay, this particular terrace. And if I just shift here, take this particular section here and go here, and there too we have a one tile drop. Okay, fine. So that's the perfect way of doing things. And you see that with that we have created all the finished flooring, which only had difference for this particular drop slabs. We have difference of finishing material, and this are the flooring which wouldn't have the drop slab or the brick bed layers for waterproofing because they are dry areas. Okay, so now we need to properly go to the section part of it and properly join all the geometries. For example, we'll start it from here. Okay, and we have curve here, so let's just take it to that particular area and just go to that particular section. Fine. So now I would say that here also there would be a beam. See, we missed it. Here also there is supposed to be a beam. So plinth floor, ceiling plan of plinth floor, plinth level ceiling plan, and here also there should be a beam, a tie beam. So the size of which will be decided by the structural engineer. I am just placing it and orientation to right. Okay, and now if I just go to this particular section, yes, the beam has been casted, but it should actually be on this concrete rectangular beam, and this should be the justification. Yeah, that's fine. Okay, perfect. No issues. And first floor plinth level plan. Yes, so see here that beam is casted. So no issues, which I actually forgot. Sorry for that. Yes, so that beam has been casted here. Yeah, that's fine. HR. And go to that particular section 2. And I will just say that HH and select this red line, which is of the AutoCAD drawing. HH just as well. And yes, the import symbol AutoCAD drawing and hide in view by category. We don't need to see the AutoCAD plans. Okay. HR and hide category this too. Okay. And let's perfectly visualize this section and join. Join this to this. So you see that the plaster layer is eliminated from that. Likewise, join this to this as well. Connect this to this. Perfect. Absolutely perfect. And here it is perfect. Here we need to join this to this, and this to this. Yeah, fine. And this to join, and this particular slab has not been casted. The snap line is wrong. So select this and go to first floor and edit boundary. Here, yes, see, it should be this line. And then finish it, don't attach. And then again go to that particular section and you see that that particular issue is resolved. Okay. Now this is going to be very interesting part and difficult also, wherein you see that you have to join this particular geometries, and there are hierarchy of steps within this. For example, if I just join first this to the external, this plaster layer, then this will make that particular layer disappear. And it will be difficult to find that once if I see join this to this, then how to bring that particular beam back. Join and switch order, and let's try. Yeah, fine. So this is exactly the perfect way. Join this to this, and yes, okay. Now also we need to join this and get rid of, yes, okay, done perfectly. Perfectly done. Now again go to this first floor level, and we are done with the horizontals, vertical section. I need to do for this same for horizontal sections also. Okay, and just join this to this to this, and this to this. Uh, join this to this plaster layer. Yes, this plaster layer, and here there is a problem of snapping of the lines for that particular thing. Join and this to this and this to this. Okay. Now, which is this particular flooring? Terrace flooring, and edit boundary, and go to first floor, and I guess that here, yeah, see, okay, and then just finish and don't attach. And if I just go to the section back, you are eliminated that particular plaster layer. Fine. First floor, come here. Let's check this particular part. I guess this would be perfect. Yeah, fine. And let me get rid of this particular and this particular part wherein exactly we will have a one tile drop. Yeah, so see here there is a problem which we need to resolve, which is this part, sec first floor, and yeah, so this is that particular part. So herein I just say that and join this to this. Oh, sorry, join and concrete with this. And because of the cut plane, we are properly not able to visualize. But this is perfect, no issues. Yes. And here join this to this. And you see perfect tile, one tile drop. Okay. And yes, again go to first floor and we'll shift this a bit. At every junction, we need to do this. Join this to this and switch order and let that concrete beam dominate and be lead. Okay. And yeah, fine. Everything is perfect. First floor, come back, come to this part. Most of the things will be eliminated. Yeah. What? Join and this to this and this to this, and okay, this is fine. Come to this section. This is perfect. Join this to this, join and this to this. Okay, now this is again going to be interesting. Join and join this to the concrete. Yes, join. Okay, first we need to join this slab with this. Okay, that's perfect. And here this is join. We just need to switch order, join and get rid of the plaster layer. And this is the perfect way we need to have the join condition. Okay, first floor, and again come to this part. This is absolutely perfect. Join, get rid of this plaster, join and get rid of this. join and get rid of this, join and get rid of this. Okay, now first floor, this particular thing, again join, sorry, join and this to this and this to this. Here everything seems perfect, no issues. First floor, let's shift to this particular curve. Yeah, that's perfect. Okay. Despite of the curve, it is absolutely perfect. Let me just hide this AutoCAD drawing, HH. Let's tab import symbol, hide in view by category, HR. Clear and 3D. Fine. So this is the way we have to perfectly snap and have the join geometries. And one thing I forgot, that is HL, and that would be the same. Let me just check which flooring. Terrace finish flooring. Okay. But terrace finish flooring, first floor RCC, HR, yes. So herein, I just need to H8 this, and let's say that first floor RCC edit boundary, and at same level, we need to create this also, and just finish, don't attach, and on the top of this, we will have the finish layer, so floor architecture and terrace finish flooring. Where is it? The terrace finish flooring, edit type, and edit 151 is 19, 12, 20, and 100. Okay, since it is exposed and will be affected by rainfall, so 100 is enough. With that, it makes it 151. Okay, apply and okay, and just create that. And with the offset of 151 just create that and don't attach. Let me just take this particular section, and you see that it's perfect, except for this should be given the top offset of how much? 15 inches, and this also top offset of 15 inches, and first floor, shift this particular section, both of this wall, top offset of 115 inches. Yes. Okay, clear. So that is how we have laid all the finished flooring layers perfectly with perfect joint condition on that particular designated floor. So now let's proceed further with the modeling part of this particular structure, where we have to elevate these walls to the level above, for which, as per the hierarchy, the first step that follows is that I will just select all of these columns. And with that column selected, I will just change this top constraint, that top level, to terrace plan. And all the columns will get elevated to that particular designated level. And then I will just say that this beams, and I say that I see that isolate that category, and from which I will just select all of this structural framing, that is the beam, deselect this, and this we don't need. Okay, and this is an entire beam, I guess. So that's why if we deselect this, then this also, let's let's say that select this, and we will just change it. So it's a copy to clipboard and paste, align to selected levels and to terrace level, terrace plan. Okay, so that all the structural framing will also, beams will also elevate to that particular level, and let's say that HR. And while coming here, I would say that I'll just go to top of this 3D view, HL, and just move this particular column, I mean the beam, till this point, and find HR. Okay, so yeah, see, it's done. Okay, now what next is to elevate the walls of this particular floor plates. Fine. So I'll just go to this particular first floor and quickly, without wasting the time, WA 9-inch wall. And I will start drafting with that particular core face exterior, the location line to be core face exterior, and the base constraint to be first floor, and top constraint to be terrace level with a negative offset of 18.5, that is 1 foot 6 inches. Minus 18.5 inch, that is minus 1 foot 6.5. Okay, and I will just elevate this particular walls. Let me just change this scale a little bit lower, and we will follow the same modeling process where we will just snap the walls as per the footprints of the floor plan. And yes, this wouldn't take much time. This would only be till unconnected height, and that would be of, okay, fine, we'll do that later. First, let's complete the walls, full walls, and snap it. Oh, hearing again, I forgot. Till this point, and then from here start 1, 2, and 3. From this point, and from this point, and this, and this. Just complete this. Okay, and also this particular walls here, from here to here, and from here to this point. Okay, and with that, all the walls are done. What left is that WA and the 9-inch wall. I'll just say that unconnected, and 9-inch of Pardi. We will create the Pardi here and here and here. No, this are, what is the width of this? It's 9 inch. Yeah, that's fine. CS, and okay, I was going correct. And also let's snap flip, flip, and flip. This would be much easier way. And this is the 6-inch parapet wall, which is already defined. Click this one, two, center. It's not, so yeah, and this, okay, and this and this. Clear? Fine. So let's see it in 3D. Yeah, fine, absolutely perfect, no issues. The walls has, yes, okay, it's perfectly elevated, all the walls. And what we need to do next is that we need to wrap the layer of plaster. But yes, some of the internal walls are left, sorry. So again, I will just go to this particular internal wall and same up to terrace level with the top offset of -6.5, and done. Okay, and here also there will be one wall which would be of this same CS. Let's select this CS, and from here to here, and from here to here, parapet wall. Okay, that's fine. Okay, let's see it in 3D. Yes, and which is this wall? Parapet wall. Okay, but parapet wall has fine. So let's just change. Yeah, that's okay. Let it be. Sorry. What is left is now to wrap the layer of plaster to the exposed structural elements, that is the column and beam. For that, again, I will use the functions of Revit, wherein I will just select this rectangular column 13 cross 19, bigger size SA, and just say that copy to clipboard and paste, align to selected levels, and I will just snap it to first floor. Clear, and select all this walls I mean this rectangular columns. Okay, SA, it will select all of them, copy to clipboard, align to selected levels and to first floor. Okay, and similarly, the beams, I will just say that SA, copy to clipboard, paste, align to selected levels and first floor snapped. And I will just select this beams, this beam wall, copy to clipboard, paste, align to selected levels to first floor. See, modeling becomes so easy with Revit that once your details are established, you just need to snap it. Okay, and this wall, I think that we need to delete it at this level. We don't need it. Okay, so now quickly, without wasting the time, we just need to join the geometries real quick. And I will say that join, select. We can do it in 3D also, and here also, one and the same. First, press tab and select the structural column and then the architectural column, and it will join. Clear? And okay, this is done. This two and this. Oh, see, tab and select the structural column first, and then the architectural column. Okay, join and with multiple join and check this to this to this, and okay, and this. Oh, yes, okay, and this two join. Okay, yes, fine. So all the structural columns are joined with the architectural columns with this. Let's check it in 3D. Fine. Okay, all the columns are joined, but the beams are not yet. So what we need to do, select this and select this one of the structural beam and say the isolate category. Press select this structural framing and then this beam wall and just say that IC, that will isolate the category. But all the this wall has also been isolated. So what you need to do, you just need to select all these walls and temporarily HA and hide it. So we can only see this much. And also I will just select all of this and say HH. So modeling becomes easy. And quickly, let's say that join, and I'll join all the, sorry, I guess that multiple join should be unchecked. So uncheck this multiple join and quickly join all the structural framing with the, yes, okay, and do it. Modeling becomes so easy with Revit. We will look this particular point later. And also this beam, from this particular beam, this needs, this plaster layer needs to be avoided, yes. And here too, join and yes, it's join and this to this, oh, sorry, join and this to this, okay. This was left, just double click and you'll be able to join it. All this areas where we have overlapping volumes, just exclude the layer of plaster. And here, I guess that we missed out. This is also left. Okay, done. And from this, just get rid of this. Okay, and I guess that we don't have anything left out and missed out. Okay, so I'll just say that select this wall and SA and pick and just pick this and flip it, join this to this. Okay, done. And I'll just press HR and let's see if something is left over somewhere. Yeah, so join and okay, join and this. Okay, done. Fine. So everything is perfect and we don't have any issues. Only thing is that here, I guess that this particular column was not wrapped with the layer of plaster. So here also that would be remaining. Just say that CS, pick lines and pick this highlighted walls overlap. Uh, let's do that particular thing. If it's creating a problem here, let's go to the ceiling plan of plinth level. And here you'll be able to find that particular beam, which is not wrapped with the layer of plaster. So just say that CS and connect and just these will connect it. Okay, fine. So it's done. Go to 3D and then you can see it, but it is entirely wrapped. So I guess that yes. So we need to go to the section and yeah. So just select that join, select this column and select this beam wall. Also get rid of plaster from here and plaster from here and also join and this. Fine. Okay, so that's done. Okay, clear. And I'll just say that HR. Yes, so this way we have very quickly elevated this particular entire floor. Now, what left within this floor, which I just forgot, which I just realized when I saw this section, that you see that this particular slabs, all these slabs, if the person standing here will be seeing the unfinished surface. So what need to be done in this case? Nothing. What you just need to do is that, let me just check in that particular project what I did, how I created the floor and plinth level working. And if I just go to any of the section, then yes. So this is that particular floor plate, floor ceiling plaster. Yeah, so that was created. I just wanted to check the name. Okay, so herein I will just go to the ceiling plan of plinth level. Yes, here it is. And whatever ceiling you see are entered, whatever ceiling you concrete ceiling that you see, just create that particular layer, that particular of floor and floor structure and sorry, not structure, floor and floor architecture, and that is going to be the finish surface. So I want Rabbit to schedule it not as a structural material but architectural finish. So where is it? Ceiling plaster. Here it is. Edit, and you see that one plaster, half inch, 12 mm. That's fine. Perfectly apply and okay. And with this, I'll just select HL and boundary line. I will just create one to all the exposed surfaces are entered and create it from here as well. This point and also to HL. This this is actually the staircase portion. So here it will not come. Yes, here, uh, here too. Okay. What is the leftovers? The leftovers, I guess, are entered. And this, why it is showing that it is wrapped with the layer of plaster. Okay, fine. Height offset to be, let's say that minus zero point 0.5 inch and just finish. Don't attach. And let's see that where did it create? Yeah, it should be minus 6 inch. Minus 6 inch. Yes. With that, now, yeah, fine. So see, perfect. But for this particular section, why it is, yeah. So we should have created for that four areas also in order to match. So just I go to edit boundary and HL and also create the same for this bathroom area, washroom areas and extended terrace and balconies and boundary line. And this I would like to do it later. First, let me just create this two, one and two, and just pick lines, one, two, tr, and join this to this, and get rid of this line. Okay, and this also was left. This also was left, and okay, now we have to create this, but I guess that the lines are not properly visible. Yeah, it's visible perfectly within this discipline. So I will just say that snap to the lines, this lines, stop here, and then HL again hidden line, and pick, and yes, tr, and join this to this. Yeah, okay. And let's use the line command now so that we can quickly do that. Li, one, two, and this portion is again confusing. R enter, okay, and Li, this connect here. I could not find the snap point, so hidden line and just pick one, two, and three, and pick four. Delete this line, join this to this, and here why is it Li? And let's now just not waste further more time on this. This actually should be, if this is the beam, oh yes, so we have snapped to the wrong location. This should be here, and this should be, in this case, here. And declines did not tr, and join this to this, and create an arch. Yes, okay. And here too, I need to snap to this line, tr, and join this to this, and arch from here to here, and yes, okay. And with that, now I'll just say that finish. Lines cannot intersect. Continue, and join this to this, and just finish. Don't attach, and let's see it in section. And you see that this has, oh, so for that particular drop slab, actually we need to create it differently because it has a different height. So again, I'll go to edit boundary to plinth floor and just say that edit boundary, and all of that selected. I will just select this one, this, and all this. Okay, and also this one and this one too. All of this, with this all selected, I'll just say that Control X and get rid of this and don't attach. And again, I will say that go to ceiling plan of this. Yes, not first floor, but ceiling plan of this, and just say that floor. and floor architecture for floor architecture and ceiling plaster with the same constraint, but I'll just say that drop of 18 inches and I will just paste because that is already drafted. We just need to assign it to the proper location. Yes, and has it properly snapped. I'll just move it. Yeah, okay. And with that, I'll just say that finish. Don't attach. And let me just go to the section and see where did it create. Yeah, perfect. Absolutely perfect. Okay, clear. So that way we have snapped the layer of plaster. Only thing is that we need to join at a couple of places wherein you see that here join and within this, yeah, this should not come actually. Join this to this, just to this. Yes, okay. And here too, and uh, join this to this. Okay, join this to this. Yes, everything is perfect now. Let's go to 3D and just have a look. Wherein what we will do is that we will just take a section box, and this time I will just pull it up in a such a way that we can see this part. Oh, that there it has not yet been assigned this part. Okay, CC and R enter. Yeah, see, ceiling plaster has been assigned to. If this was not there, then you see the RCC slab. But with this, now you see the ceiling plaster, and only this part is left, which is again a drop slab, I guess. Which portion is that? That is, yeah, again a drop slab. So that too will have section 2 and first floor. And let me just take this particular section here. And I forgot within that or what. Yes, I did forgot. So that's okay. I just say that edit boundary and go to reflected ceiling plan of first floor plinth level. Yeah, reflected ceiling plan, plinth plan. Yes, and you see that I missed this. So just create one and just finish it. Don't attach. And with this now go to 3D and you see that it appears there, but at the wrong place, I guess. What mistake I did. Minus 1 foot 6. Yes, and finish. Don't attach. Yes. CCR enter. Okay. Perfect. Okay. Done. So let's further proceed on with the modeling part of this particular structure from the terrace level. We have to lay the flooring for terrace plan and elevate this particular stair cabin. So I'll just go to this particular first floor. Now, first floor is done. I guess that's ceiling plan of terrace level. Yes, and herein we need to snap the AutoCAD plan. But we need for that purpose, again, I'll have to look if we're going to find any common point of this AutoCAD plan. So I'll just go to this particular terrace level and say that insert, import CAD, navigate to that particular location and terrace plan. Where is it? Yes. Inch and manual center. Okay. So where this is the common point, the staircase, import categories and turn the terrace plan to halftone, apply and OK. So I'll just go to this particular first floor and herein I'll just check wireframe sorry, HI and I select this and draw a reference line. Select this, edit work plane and snap it to terrace plan and just say okay. So terrace plan, and which was that point? Yeah, sorry. Okay. And herein, I'll just move this point and snap it here. So this is how we position the AutoCAD floor plan. I just right click and call this hide in view by elements category. So this is the terrace floor plan, which we need to elevate further. So I just HR and go to 3D. And for this particular floor plan, what we will have hiding view by category. What we will have is this particular only this columns, which will be, but first let's draw the floor plate. So things will be clear much more. I just come here, architecture and floor structure and terrace floor RCC. Okay. And 0. Yes. And boundary line. Just draw this line and create this TR, join this to this, join this to this, join this to this. And actually, this will not come. Okay. And we need to get rid of this. We won't have a slab here. So actually, yeah, that was correct. Let me just click undo. This will go here and LI. This will connect TR and join this to this. Okay, fine. So this would be the slab for that particular terrace level. And just finish. Lines must be close to TR and join this to this. Finish. Don't attach and hide this icon elements. Okay, CC. Fine. Perfectly. Perfectly created. Okay. Now we need to join again the geometries. So I'll just quickly go to modify and with multiple join checked on. This will just take a bit of time. So just stay tuned and be with me. Getting rid of the overlapping volumes. Okay. Yeah. Yes, it's done almost. Mm, join. Yes. Okay. Fine. Perfect. CC R enter. For CC, let me just see that this is left. Yes. Okay. Even this. Join and this. Clear. Realistic. Fine. So now let's take the columns for that particular floor, which would be the stair cabin is here. Only this particular columns. One and two, three, four. Only four of this. Let's just project it so we'll come to know. Laptop. Yes. Absolutely perfect. Yes. Fine. No issues. And let's create the finished flooring for this level. Here, this is left. Join. And this is actually the, yes, it's wrongly joined. H and join and select the structural column rectangular. H something. Sometimes something creates problems. H and join and select the structural column and join with the architectural column. CC and R enter. Yes, fine. Okay. Yes, clear. So also the structural framing needs to be this and this. Say that IC, isolate category, beams or beams. Select a beam, select a column, and IC, isolate category. That's fine, perfect. And select all these beams, copy to clipboard, align to selected levels and to terrace plan. Yes, undo, and this was popping up already at terrace plan. Sorry, this was already putting up at terrace plan. We were supposed to snap it, copy, paste, align to selected level, and slap top. Yeah, TR and join this to this. Perfect. HR. Yes, yes. So now let's go to terrace plan level and quickly create the finished flooring. I guess that we don't need this AutoCAD plan now. Hide in view by elements. Yes, and I would just say that floor and floor this time architectural and terrace finish flooring. This is it. Edit type, edit, and it has this brick beds for waterproofing since it is going to get affected by external rainfall. Sand bedding, PCC, mortar, and terrace finish flooring. But I would rather suggest that go to length and turn this to millimeters, rounding up to two decimal places. OK and OK, and then go to edit type of this 151. Total thickness is 151, 100 of brick beds, sand bedding, and 12 the binding element mortar. And this is the terrace finish flooring, wherein I have applied this material. This is just a JPEG image, China mosaic flooring. Okay, and OK and apply and OK. And with that, I'll just create a boundary line, which would be along the entire periphery. Pick, picking was much more easier. Why was I drafting? Okay, fine. And 151 mm offset and just finish it. Don't attach. Go to 3D. Fine. Perfect. And is that the same way it persists here? Okay. This. Perfect. No, at this particular level, terrace level. No, that is first floor. This is terrace level. So here will be this particular. So we need to get rid of that. Sorry, I did a mistake. And this would edit boundary and stop here. Just get rid of these lines. Finish. Are there two lines? Let's go to terrace level. Delete. Yes. This ugly sound irritates me a lot. Don't attach. And this would rather tr and join this to this. And don't attach. That's fine. 3D. Oh, perfect. Clear. And draw the parapet walls for that particular designated floor plan. WA and parapet wall, or actually not parapet wall, the main wall only, but the constraint would be different. And now I guess we need the AutoCAD floor plan. Unhide in view by elements. Turn on the bulb. Yes, turn off the bulb. And wireframe, HL wireframe. Okay, and WA, that is wall. And I would just go to the main wall, 9 inch, and base offset 0, and base constraint terrace plan and up to slab top. That's fine. And just draw this from here to here and then snap it. Move, move it 0.5 of an inch, and it's perfect. Change the discipline to fine. Okay, clear. But all of this four walls, 1, 2, 3, and 4, will have the top offset of minus 18.5 beam depth. Yes, and join structure with this walls, join and multiple join and check what is the problem. Join and this to this, yes, this to this to this. Clear? Okay, and then WA and terrace plan, but this time the top constraint would be unconnected. It will be just a 3 feet of parapet that we will draw from here to here, and we'll follow this footprints of the floor plan. We will stop here, continue again from here, and that is how we will complete it. Okay, and here I guess that I need to merge it, but that's okay. We need to host architectural columns here, and I would just like to go to join condition and say that disallow. Snap press here and make this, where is it snapping to? Join. Yes, okay. And HL, disallow. Okay. And this I need to split and join. Yes, this would be only till here, and this would be till here. And likewise here, this two split element and join. This would be till here, and this would be till here. Yes, and join. Okay. And also we need, yeah, fine. So join options we need to properly work out. This I guess that is wrongly CS, and let's snap it. TR and join this to this. Yeah, that's fine. Okay. 3D and okay, perfect. And let's wrap the layer of plaster to this particular exposed column and this particular beams. And we will just say that this rectangular column SA, that will select all of this. I will just make a cross window, deselect this too. And with that two both selected, I'll just change the top level to, let's say that slab top. Oh, wow. Okay. And likewise, I will just select this two, SA, and deselect, make a cross window, deselect all of this, and this too. What we just need is just to SA and deselect this all. And with that selected, just say that the top level should be slab top. Done. Fine. Okay. And oh, I guess I missed one wall over here, this particular part. So let me go to first floor plan and CC, CS, and just say that close this and complete it. Yes, just HL and hidden line, but that wall would be snapped to terrace plan. It will be full wall herein wherein we'll have door and access to this terrace. Yeah, perfect. Likewise, just say that WA and yes, this beam external wall plaster, okay, beam wall, and just change this constraint from base constraint terrace plan and base offset to top level slab top, which would make the unconnected height 18 inches, 18 and a half. Just snap it. One, two, three, and four, five, and six. Okay, and just revert. Just press space and snap it the place where it is supposed to be. Press space and then join. Yes, okay, and cancel. Switch join and join this to this. Join this to this. Okay, and also we need to get rid of CC and join. Select this column and yes, okay, perfect. Also join and get rid of this overlapping volumes and here too. And I hope rest everything is perfect. Done. R enter. And see something always remains. And this here too. Join. Okay. But I guess that this should be mm, yeah, because here there is no column, so it couldn't find. Yes, so this particular column, both of this particular, it should be main wall. I'll just go to top here itself in 3D and just connect. Okay, and yes, done. Join and okay, perfect. Clear? Yes, it's done. And this got disconnected. just delete that wall and again say that here also join and yes, okay, and just select this and say that CS pick, press space. This beam, yeah, sorry, this particular beam is of bigger size. It's 12 cross 18, and this particular beam is so the plaster wall which we will but here it got snapped. Why is it not? Yeah, okay. So WA and I guess that the beam, wrong beam has been placed. It should be 9 cross 18. Oh yes, perfect. So that was the problem. So CS and just pick revert, join. Okay, done. CCR enter. Yes. Okay. And finally, the slab top. So I will just go to this particular laptop and we couldn't see anything. So I'll just change this particular range level to terrace floor plan, terrace plan. Yes, and click with that. We can see the footprints. And from there, I'll just go to floor, architecture and floor structure and slab top. I guess terrace floor RCC, the same. And I'll just create one, which I would snap from here till here. Okay. And slab top and just finish. Don't attach. Get rid of this hidden view by elements. Okay, fine, perfect. If you want, you can just create a wall of 15 inches on that particular level, WA, and I will just change this underlay now to none. Yes, and WA wall and main wall 9 inch. Okay, and slab top base offset to be 0 and unconnected height to be 15 inches. And just create that with the code face exterior. Just flip the direction and create it. Yes, let's see it in 3D. Wow, absolutely perfect. Fine. So this is how we have completed. And on this laptop, we will have again floor, floor architecture, and that same terrace finish flooring. I just click the boundary line and just create it with the top offset of 151 mm. That's fine. And done. And don't attach 3D. Yeah, fine. Okay, clear. And then if you want, you can just extend this column up to match this face, but that's not important right now. Okay, clear? So that is how we have done with the modeling part of this particular structure. Now what we need to do is that we need to add the ventilation, door windows, human figures, and whatever needed to this particular project. But before that, let me just go to the terrace level plan, and herein I just delete. Yeah, fine. Why delete? First floor, and I have this section. Why is that section not visible in this floor plate? Just delete. Okay, delete this as well, both the sections, and draw it here. Now I don't need this AutoCAD plan. Hide in view by elements, and just take a section. Yes, and I 8C hide category and hide category. and change this to fine. Okay, so with that, also hiding view by category, the AutoCAD floor plan. We don't need it. Clear. And H, hide in view by category. All the AutoCAD plans, I don't need to see it. And what I need to see is this, wherein I would just say that modify and join this to this. Perfect. And join and switch order this to this. Yeah. Join, switch order. Okay. And likewise, I'll just go to this first. Take this section over here. Okay, it's perfect. Yes, here. Join and switch order this to this to this, and the wall should connect with the RCC slab. Join and switch order. Yes, complete. Let's look at this place also. And join this to this. Yes, this is already joined. Clear. And again, go to first floor. Shift this section a bit. Join and switch order. Okay, this is perfect. And the last segment, just shift it here. Okay, and just go to section. And yeah, see, it's absolutely perfect. Perfect join condition and perfect everything everywhere. And you see that this remains. Let me just scale it down a bit. Yeah, join and join this to this. Switch order. Perfect. And join this to this. Join this to this. Clear? This is how you work with perfection in Revit. Let me just go to 3D and let me just close this unnecessary views. Fine. So the modeling part of this particular structure is complete. Fine. Now we need to add the door windows and everything. And one thing I would like to bring to your notice that you see this particular lines. So just say that select this particular thing and I see that will I select the category. And with this, you can just real quick join in order to get the perfect visual appearance and don't see that particular black lines. Or join and join everything, and that would be very easy. Yes, and here there is some problem wherein you see that it says that, oh, let's just ignore that few portions. Join and join this to this. Yeah, see, so this part is problematic. We will see, check it later, but rest complete with all the other, which is perfect. Yes, so here there is some problem of little micro error. Join and it's everywhere creating a problem. Doesn't matter. Okay, fine. And join all of this. One to two, one to two, one to two. Perfect. Mm, Likewise here as well. One to two, and all the black lines will be eliminated. In order to have perfect visual appearance, it should look one uniform surface. The purpose of this thing is that we need to make that we need to make it look like one uniform surface. So that's why. And if your modeling is not perfect, it won't join. Just like we had that problem in that particular stair cabin area. So you need to be very particular from day one for your modeling part and the join conditions of 3D elements. Join and this to this. Join and this to this. Perfect. And likewise, join and this to this to this. Yeah, okay. So see, now if I just press HR and you see that it looks one uniform surface for your entire build. Okay, one uniform surface, except for, let's just do this also. I'll just take this column, and this, and the one that is hidden here, which would be, I guess, this. And I would just say that this laptop on top of set to 15 inches and elevate that columns, that position, join this to this. Okay, and herein, join this as well. Oh, yes, okay, and join this as well. Okay, and just select this particular rectangular column and just give it a top offset such a way that it flushes here, and this to 15 inches. Okay, and this to 15 inches. Yes, fine, absolutely perfect, and no issues. Just make this join to this also in order to make it look one uniform surface. Yeah, okay. And all the flaws have been eliminated. And look, I forgot this particular, absolutely sorry. See if you just, yeah, here there will be a slab as well because, yeah, there's an opening over here and this curtain wall will also go up till this point. So I made a mistake here as well. Sorry. Just delete this two walls and that wouldn't take much time. H this and edit boundary HL and just go to terrace plan, select this line and draw from here. Yes, and connect these two and just finish lines coming up TR and join this to this and just finish. Don't attach. And with that, the finished flooring as well. So let me just change this change level to none and select this, edit boundary, connect and finish, don't attach, continue this wall, CS and just connect and go to 3D, R enter, fine, HR, it's done now, perfect. Only thing that's, let's just check it in section once, whether the join condition is proper, and no, it's not. So fine, and just join this to this, switch order and let the masonry part touch the RCC slab. Join this to this. Yes. And also here. Yes. Join and okay. It's done. Fine. Go to terrace plan. Just check this section once. And here also, just join and switch order. Okay, done. Fine. We'll go to 3D. And what you notice is that now for your entire 3D model, you have one uniform surface. Okay. So now let's add the door, windows, openings, and other attributes and assets to this particular 3D model in order to complete the modeling part. So for that purpose, I will just go to this particular road level plinth, I mean floor plan of plinth level, and we will start with this particular multi-purpose room first, wherein I'm just going to add a couple of curtain walls over here, which would act as a glass slit. So I'll just click this WA, and you see that already that particular thing has been defined. Curtain wall glass slit, and if I just go to edit type, then this is system panel glazed. It is reading the curtain panel, it's system panel glazed, and we don't have any division. So with that, I would just come to the base offset and define plinth level and unconnected height. I will just go to this first floor and give it a top offset of minus, let's say, 18.5. That would make it unconnected height 7 feet, 2 feet, 2.5. That's fine. And I'll come here and just define a glass slit of 1 feet. And with that, I will just copy it multiple times. One and two. Okay. And you can just, oh, sorry. Mm, sorry. Wireframe. And then I'll make a, okay. And you can just adjust it as per your requirement and your size. CEO. And I'll just copy it one more time. And let's go to 3D. Okay. So that particular glass slit appears. Now, what you need to do is that I would just select SA, all of them, HI, and I'll just go to this particular mullion, and I will just host this 1 inch square, all grids, 1, 2, 3, and 4, HR. Yeah, fine. So that glass slit has been defined. Now, next is that herein, for this particular portion, I'm just going to load, let's say that WA and angled curtain wall. It is a parametric curtain wall. You see that the curtain panel is reading and angle curtain wall with the fixed distance vertical and horizontal to be 2 feet by 2 feet. And I will just snap it this point. So you see that it multiplies on the basis of the total dimension. I'll just make this 8 foot. Okay. And here I'll just extend it here so we can have a full at this end. And I'll just click this CS. And again, with the same constraint and with this angle curtain wall, I just snap it from here to here, 6 foot. Okay, and I'll make this 6 foot. Yeah, okay. So it complies. And let me just go to 3D. And you see that if I just select this and just press space. So you see this is the parametric curtain wall, which if you want to learn the fundamentals and basics for, then you should enroll for this particular course. And then I'll just click this DR and we have the sliding folding door window B type. That is also a parametric door. And I'll just flush it. It will just take a bit of time to regenerate, but heavy family it is. So just stay tuned. And you see that it's loaded. I'll just go to 3D and you see that it's completely parametric. I will just select this particular window, get rid of this parameter sunshade. We don't want the sunshade. Okay. And for this particular casement and awning window, I'll just say that 45 and 45. That will open up. Okay. And you see that this is a complete sliding folding door window. Clear? And I will just snap this same CS and from here to here. How much is it? 10 foot. I'll just, we have to do it in the multiple of two because one panel is 2 feet. So that's okay, fine. And I'll just go to Plinth level and herein I'll just add ventilation. So WN and this Windows louvers 24 cross 24, still height 6 foot, and I'll just add it and add it over here. And yes, it's been added, but you cannot see it because of the cell height. If I just go to 3D, then you can see it. Clear? Now herein, as per this design, if you watch, then here is the corner slit window, curtain wall, glass slit corner. And this corner window, how to define a corner window, I'll just show you. So let us go to this particular project on which we are working. And herein, I will just go to the ceiling plan of plinth level. Okay. And herein, I'll just say that WA wall again. And that would be curtain wall glass slit corner, which is referencing this basic wall, glass wall 2. And what is that glass wall 2? WA, and if I just drop up glass wall 2, edit type, edit, and it is basically a wall only, which has been assigned this material of dark glass, and its thickness is 1 inch. You see that the material of dark glass has been applied to it, okay, and it has 1 inch of thickness. And this particular glass wall, we are going to reference. I have reference in that particular curtain wall glass slit corner. If, okay. So with this, and now I will just say that the base offset to be 6 foot because you have to match with the ventilation. And that's why I opened up this particular print level ceiling plan and top constraint. I would just say that in order to make it exactly 2 feet, I would just say that I would add 5.5 inch to this. That would make it 1 feet minus 1 feet, 11 inches. So that's also 2 feet. So minus 2 feet, I guess. Yeah, fine. Okay. And with that, I will start drafting this, but you cannot see it because of the view range. You essentially need to change the view range in order to see this. So print level and view range. And right now the cut plane is 9 feet. I'll just make it something like 7 feet. And yeah, so see, the full window is visible now. I'll just press WA and that would select this glass wall slit, which we hosted here. But now I will just select this glass wall slit corner. The difference is that this glass wall slit is referencing the system panel glaze. Okay. But if you want to have the corner window, you essentially need to change this to basic wall, glass wall 2. Okay. Which is this glass wall 2, WA. And if I just come here, then you see that this is the internal wall and glass wall 2. Yeah, this is basically a wall only, but it has been just structured and layered in such a way that it is having a thickness of 1 inch and it is referencing this material dark glass. This is the material which it is referencing. Okay, so in order to have a corner window, we need to reference this wall only within that curtain wall. So WA, and I will just select this particular glass wall slit corner, and I will just snap it from this point to this point, and from there WA, and I'll just reference it roughly something like this. Okay, and this is not properly hosted, so I will just snap it from here to here. Okay, now what we need to do, we need to select this and move this particular face here on this extreme edge, then press tab until we select this particular glass wall, which is the reference within that curtain wall, and then just unpin it With that unpin, just move it. Okay. And then you see you have a corner joint. Just like that. Same for this. Move it and move it to the extreme face with this selected, with this glass wall selected, unpin it and move it on the exterior face. Okay. And with this now, what you can do is that select this and flush it. And you'll have a corner joint and corner window. See, 3D. And you see that it absolutely perfectly appears. And if you want, you can go to architecture, mullion, one square, all grid, and just snap mullion to that. And with that, just select this corner mullion. In order to select that, what I need to do, select this curtain wall and this curtain wall. Press tab. Let me just go to plinth level. Sorry, plinth level floor plan and this. Both the curtain walls, I'll just select 3D and HI. Fine. And with that, I'll just say that this corner mullion, I just delete. And for this corner mullion, I'll delete this as well. And we have a perfect corner window with perfect joint. Okay. So this is how you model things in Revit. Fine. Let's proceed on with the main structure. I'll again go to this particular plinth level. And herein also I need to create one corner window. If you just watch this, then you see that here also there is the same curtain window. But here we don't need to flush it to the exterior face. We will just snap it here itself. So how to do that? And come to this particular project. Wall again, wall, curtain glass wall, slit corner, and with that constraint base offset. Now this will change again to 15 inches and top constraint to first floor and minus 2 feet. Okay, and I will just draft it something from here to here and just randomly from here to here. Now, in order to make it a corner, we will just follow a different method wherein I'll just select this wall. I'll just select this wall, this wall, this curtain wall, and this wall, and go to 3D and HI. Isolate that elements. Okay. And with this, now I will come to this particular wall, edit profile, and then I will just click pick lines, and then I'll just select this work plane, this work plane, this work plane, and we are just editing the profile of that particular wall. And I'll just finish it. And likewise, I will edit this profile and just follow the same steps. That is, I'll pick lines, one, and this work plane, and just split and TR and join this to this and join this to this and just finish. So with that, now you notice that your corner window is not flush to this surface. It is in the middle, but still it is joined perfectly. And if I just go to here, and you see that perfect joint condition. Okay. And let me just reduce it a bit because here there will be a door and just expand this. Yeah, fine. Let's go to 3D and HR. And yes, it's perfect, absolutely perfect. Fine. Now I'll just go to plinth level, DR, and this parametric door. I'll just load it, which is that, yeah, this is that door, and I'll just load it. Okay, it is also parametric door, but you cannot see the swing because we need to elevate it to the finished floor level. So height offset 114, I'll just copy it and that too, cell height. And yes, with that you can see the swing now. And I will just click WN and this fixed window of any size, not important right now. Just select 38 by 38 cross 36 cross 48, edit type. Yeah, that's fine. And we will just make it height. We are going to give it a sill of 15 inch and its unconnected height should be 8 feet. So this would be 6 foot 9 inches. Apply and OK. And just give it a sill height of 15 inches and flush that window as well. Okay, now let's go to 3D and see. Fine. Perfect. Okay. You see that the lintel matches. Okay. And for this particular door, I'll just go to this material category and I'll just change it to SAT, the existing material of Revit, copy and paste paste, and the heavy parametric doors. So it will take a bit of time to regenerate, and everything I'll just make it equal to uniform, same material, paste. Okay, yes, fine. So you see that we are done with it. Now we have to proceed further, load the windows and doors onto this other required spaces. So again, I'll just go to Plinth level, and first we'll complete the Plinth level and WN. And here the window, what window will it come? Here is the simple window casement double. Okay, and this is the window with side light and transom. Again, this is the parametric window. So window casement with double and 510 cross 5, it exists. I just snap one and two. I forgot to change the sill height. I just change the sill height to 15 inches and this to 15 inches as well, because the height of that is 5 feet. So 15 inches and 5 feet. So yeah, we can just keep it 3 feet for both of them. So height is 5 feet and 3 feet of sill. So that will make the lintel 5 feet, 8 feet. Okay. And likewise, here we have a different type of window, WN, and that will be this box window, this 60 cross 60, 24, and cell height of 2 feet, and its own height is 6 feet. So I'll just place it here. Yes, okay. The another one, which has some dimensions edited, wherein you see that the height is 6 feet and the width is 8 feet. Okay, yeah, fine. Now, let's add DR door, a single flush door over here, 36 cross 84, and cell height of 1/4, 1.25, finished flooring, and the tab. This would be one door. This would be, yeah, here there is a storeroom. I forgot to place the walls of that, but that's okay. You can just do the needful. And DR, and now this parametric door, type C, decorative. Again, I need to give it a cell height of 1.25, and all this materials. I just click Control V and Control V and Control V and just place it. The parameter doors here and here and one over. Press space so that will invert, flip the swing angle. Okay, and WN, and here is that window casement double. No, not that. Which window is popping up here? Window double hung. Let me just check. Window casement double 48 cross 60. Window casement double. Window casement double 48 cross 60. Okay, and with that same cell height of 3 feet, I'll just one and two. I just needed to move it a bit, and that same exists everywhere over here. One and two, one and two. And here there is a storeroom, so there will be a ventilation over here. And again, if I'm not sure whether there is a glass slit there also, no, it's not there. Yeah, fine. Here we have this box window. No, that's another portion. Two windows, right? Yeah, fine. And because yeah, I said for storeroom, you again have this type of glass slit. Okay. And here is the simple slits. So WN and just select that not that those will not be the windows, but those will actually be this. So CS and just create one and CO, copy it 20 inches and create a couple of them, one to two, and three. That's fine. Let's get rid of this because here there is a storeroom wherein we are going to define a slit just like this. Okay, now here there is one column also. So this is going to be interesting. And again, say that CS and place this, press tab, and yeah, the constraint are the same. I'll just place it here, and this I will place it here, flush it. Yeah, okay. Now I will just select this, and just like the same process that will follow, I'll just move it from this edge to this edge. Okay, I move this from this edge to this edge. Okay, and then I will select, press tab and unpin this and move it from here to here, and the cut still exists. The same process, select this, unpin, and move it from this point to this point. Okay, and just select this and extend it all the way till this point. Select this, but I guess that we need to snap it to the exterior face of the plaster. Press, this ugly sound, I hate it. Move it from here to here. Yeah, fine. And move this from here to here as well. Okay, but it's unpinned, so the cut still remains. So you don't need to worry about it. Select this and join TR and join this to this. Or select this and snap it to this. Fine. And perfect corner window we have. Absolutely perfect. You see that the column is visible with its finished surface of plaster layer wrapped to it. Okay. And now I'll just go to this particular architecture and mullion and snap all grids 1 inch square. And I hope that you know that how to get rid of this. Just delete and press tab and delete this as well. Okay, clear? So that is how we have placed the corner slit for this particular area as well. This all I need to change. Go to edit type and clad white. I'll just say that slash and this to share as well and apply and okay. Okay. So yes. And this swing has accidentally opened on the wrong side. 3D swing angle, I just changed it to 45. And let me just check this as well. Yeah, this too. Just change it to 45. All these are parametric door windows. The basics and fundamentals of which, if you want to learn, then you have to enroll for this particular course. Okay. Now, what next is that I will just select this one, two, three, copy to clipboard and say that paste align to selected levels, and I'll just place it to first floor. But of this, I will just select this and change this to windows with side light and transom. But essentially, it will flush, it will collide with the beam. So what I need to do, I need to change its cell height to 15 inches. Okay. And for this too, both of this, I'll just get rid of this source and shade. Okay. Yes. Now, what let's put slits over here as well, both the levels and plinth level, and just select this CS and which area that was. Acha, okay, this wall, sorry. So just place it 1 feet, copy it, one, and copy it, two, and three, roughly. Select all of this, copy to clipboard, paste align to selected levels to first floor as well, and go to 3D. Fine. Clear with all that. Select SAHI and just say that architecture and curtain grid and sorry, curtain grid name, mullion, and for all grids with that square 1 inch, 1, 2, 3, and 4, 1, 2, 3, and 4, and HR. Clear? Yes, but I guess that no, it is not getting conflict. Okay, fine. What else? Okay, fine. This is done. And here there is a door. Okay, so let's place a door over here and just select this door, CS, and place it over here. Okay, fine, perfect. Yes, and here also perfectly placed. Yeah, 1/4 cell height copy instance parameter, which we need to do it here as well. Yes, first floor and cell height 1/4. Yeah, that's fine. Okay, and also this slits are here as well on the topmost level, and also there will be a door. Let me just check. Yeah, door and all the slits all over. Okay, fine. Come to this, select this particular slit, CS, and roughly, but you cannot place it. You cannot do a create similar of this. What you need to do, you need to go to the terrace level plan. But before that, let me just place a door over here and place a door over here. Press tab. Okay, and we need to elevate, and the finished flooring of this is, let's say that, yeah, height offset, not that. This is actually the total of this is 151 mm. So I need to give it a sun height of 151 mm. Yes, so the full door is visible. Likewise here too, 151 mm, the finished flooring. Okay, and then I'll just go to this particular terrace plan, and herein I'll say that WA and curtain wall slit and 1 to 2 and 1.3 and yeah, that's fine. Copy a couple of them, 1 feet 6 inches, CO, and copy it from here. Select all of this, DM, that is mirror, place it, fine. And the same you can do it here as well. 1 feet, copy 18 inches, CO, copy it multiple times. Okay, and just position it. Oh, sorry, wireframe, and then copy and just shift it. Okay, 3D, and yeah, fine. Okay, now what next is that the leftover here I forgot wall only or what? Plinth 7, no, sorry, first floor and CC, and I actually forgot a wall over here. CS, create similar, and first floor and up to terrace level, 1 feet 6.5. Well, with this location line selected, let me just create a wall, go to 3D, and the beams were already posted. Yeah, fine. I forgot the wall, but the beams were done. And go to the section and just join this particular wall with the flooring. But right now, I'm not considering that part. Okay, fine. Let's just do it. Come here and just join this to this, this to this. Okay, this is also left. Okay, that's fine. Now Herein, we have placed all the ventilations for this door windows for this particular. Only this curtain walls remain. This two curtain walls that will do it together. But let me just go to first floor, and herein I need to say that HL, DR, and the single flush 36 cross 84 with the height offset of one. What is the finished flooring for this? The 51 mm. Yeah, I remember. DR and single flush and 51 mm, and just host this door. The full door swing is visible, and also it's somewhere over here. Okay, and now DR, and here there will be the sliding folding door, the still height of 51 mm, and we are going to host it here. Yes, just shift it a bit. Does this belong to A category? Some larger size? Yes, that is the door of some larger size. So that's okay. And I will just come here and get rid of the ventilation sunshade. Not ventilation, sunshade. Yeah, fine. Okay. And I'll just go to this particular casement 45 and awning also 45. That will open up. Okay. And what else? I need to check here. Okay, these are the same, this type box windows. And here there also there is a corner slit. Okay, so we'll come back to this particular project, and what I will do is that here there is a box window. So first floor and WN, and this window with a cell height of 2 feet. That's fine. But I guess this would be much better with bigger dimension. Yeah. Okay. That will entirely occupy. Let's go to 3D. Yeah, fine. Much better. Okay. And the corners left for this particular this wall. Do we have any elevation treatment there? No, we don't. So that's fine. I'll just go to close this unnecessary news and ceiling plan of first floor. Ceiling plan of first floor, and here at this point, let me just come to first floor and say that WN and host a louvers window first with sill height of 6 feet, and that would be this corner. Okay, and just move it from this point to this point. Okay, again, this will be a challenge creating this particular. Okay, and view range and just change it to 7 feet. So again, this will be a quick revision to how to create corner window where wherein you have the column here in this case and a window. So I will just say that WN, sorry, not WN, WA, and corner window, curtain glass wall slit corner. From here to here, I'll create one. What is the, yeah, so top constraint should be base offset, and top constraint should be minus 2 feet 1 inches. That would, minus 2 feet, I guess. Yeah, fine. And then I will just create it from here to here. One, snap it, and this would be roughly undo, and from here to here. Okay. Now I will just select this, move this face to the exterior most. Same for this, flush it. Okay, and just move it this face exterior most, press tab, unpin it, and then move it from this point to this point. So the cut still remains. Press tab, unpin, move it from this point to this point. Okay, and just TR, join this to this. Perfect. 3D. Wow. Clear? Okay, fine. So now what left is hosting all the different types of curtain walls. Rest we are done. A curtain wall that would come here, that would come here, that would come on both this faces, and yes. But before that, let me just go to first floor and WA and curtain wall glass slit corner and offset to, let's say, 9 inch and unconnected 2 feet 3 inches. Sorry, 2 feet 3 inches, and I will just host 1 to 2 and 1 to 2, and just like that, CS, and from here to here, and just snap, and again line, and from here to here. Okay, and just get rid of this, and again wall, that curtain wall glass, that same with same wall, and create one, pick, and this. Okay, this and this, but this got inserted inside also. That is don't that we don't want. Okay, let's go to 3D and check. Yeah, fine. So see, all the glass railings has been added with that particular glass piece following the curve footprints, because that is referencing actually a glass. It is not a. If this is a system panel glaze, then you won't have the corner properly defined within. Okay, so you see everywhere it is perfectly referencing. Fine. So now what we need to do, we need to place different types of curtain wall, and let's first start with this. Okay. So I'll just go to, and this will be done in a different way again. I'll come to this particular plinth level, and herein first I will just go say that architecture, and this wall opening, and I will just create one roughly. Yes, and I'll just snap it from this face, something like this, making it equal to something like 12 foot. Okay, and its height is top offset is -2. Base constraint is plinth level, and top offset is first floor. So top offset should be minus 18.5 inches, that is beam depth along with the plaster layer, and base offset should be only 6 inches enough in this case, or let's say 9 inch. Okay, let's take this particular section over here, flip it, just expand the view range a bit, and come here and just hide in view by category. Okay, CC. Yes, so this is the cut that has been performed. I will just select this and say that copy to clipboard. And I'm not sure whether this will work or not. First floor. Yeah, it does. Perfect. Okay. And with this two cuts defined, didn't I tell you at the time that the actual height of this particular thing will be decided on the basis of this opening? Fine. So now what you can just roughly, as you could go to a different place and just with the extrusion end, you can just place it 3 foot. 3 foot is too much. Let's keep it 2 feet 3 inches. Yes. So that's one step down. Okay. For that, perfect. Okay, done. Now we need to place the curtain wall here. So I will just come to this particular plinth level. And let me just hide this AutoCAD plan. It's disturbing. Hide in view by category. Or let's just temporarily hide it because in order to define the road network and everything, we will need it again back. So herein, I will just say that I would just place WA. And for that also, I have a curtain wall glass water body. Curtain wall glass, curtain glass wall water body, edit type. And you see that for this, the system panel glaze is designed because we don't have a corner joint. Okay. System panel glaze is defined for this particular curtain wall because we don't have a corner joint. And just say that base offset should be 9 inch. That is what the constraint of that particular cut. And the top offset should be terrace plan with minus 18.5 inches. Okay. And with that, I will just draft this particular wall from this end to this end. Okay. And just go to 3D. Wow. Fine. So the curtain wall has been defined. Perfect. What we just need to do is that you need to place the divisions and assign mullions to that. Okay. So I will just go to this particular section one and I will just say that HI and go to architecture and no, but with we need the reference how to place the grid. Okay. So I will just go to architecture and grid curtain grid and just roughly define. Yes. And this should follow roughly this one and herein this two. Okay. And the rest is that a door will be placed here and herein this would be, let's say that 7 feet. Okay. And then again, I'll just go to curtain grid and with one segment, not one segment, all except one pit. I'll just define couple of 1, 2, 3, and I'll just, oh, sorry, curtain grid and all except one pick. I'll just select this and get rid of this. Okay. Again, I'll place one more over here, get rid of this, place one more, get rid of this, place one more, get rid of this. Okay. So this is the grid that we have defined. Okay. Now just go to Madian and for all grid, this time I will select this 1.5 cross 2.5 rectangular and with one click I'll just assign the mullions to all the grids and for from this I just need to get rid of this mullion or just delete it and select this panel, press tab and select this panel, unpin and go to the door. Where is the door? Not there. Fine, doesn't matter. We will do it to insert, load family and libraries, English Imperial, US, window, and herein we have this curtain wall, or sorry, door, not windows. So US and door, and we have this curtain wall, this double storefront, and just open it. So with this, now I press tab, and with that unpin, you can reference a door also, door, yeah, fine. And just select that door and go to edit type, change this to sash, copy and paste. apply, okay, and just go to edit family. And for all this, for this go to visibility settings and just check all this particular levels and visibility settings and detail level. Make it true for all the details level and just load it back into the project, overwrite existing version. So the handles are also visible now. Okay, clear. Go to 3D and you see that you have your curtain wall perfectly defined, except for this glass to be one dark glass. Okay, and it will accept because that material of dark glass do exist. Fine, clear. Now we will define the curtain wall for this particular terrace option, terrace wall here, this place. So that would be really easy. I will just go to first floor and say that WA, just not join or join it this to this, join. Yes, okay. And WA, and this time the curtain wall, first floor, double height, नहीं, curtain wall, glass corner, living, नहीं, कौन सी है? Sorry, even I forgot. Which is that curtain wall, first floor, double height. Yeah, very thing. Fine. So curtain wall, mm, double height. Yeah, curtain wall, first floor, double height. Just first floor, and rest of the constraint remains the same. And with this, I would just say that I don't want to manually, but now if I will reference the grid and mullions in this, then it will reflect in all others also. So I will just do the needful, wherein I'm just going to say that go to that particular option, CC, and herein just architecture and grid, and manually define 1, 2, 3, and 4, 5, 6, likewise, okay. And then I'll just say that mullions, and that with same mullions, all grid, just snap it, 3D. Okay, so the curtain wall for that particular part is defined. You can decide the division of grids manually as per your design, as per your requirement. Okay, and herein for this particular section, for this particular, I would just like to select all of this and select and filter and just say that curtain wall mullions, apply and OK. So make continuous. Fine. Okay. Section 2, the wireframe. Again, you need to be very careful. Select this, make continuous. Select this and make continuous. Okay, 3D. Fine. Now, what needs to be done is that for this particular slits, yeah, okay, no issues. You can host mullions to this particular slits also, but right now I'm just proceeding further, and we will come to this later. First is that I need to complete this curtain wall for restroom and see WA, and that too appear differently. Curtain wall for restroom, where is it? Yeah, first floor relax, not restroom, sorry. First floor relax, which will have the same constraint, and I will just place it from here to here, and this from here to here. And let's just snap it all the way till this point. Oh, okay, and join. Yeah, yes, from this to this. And this too, I guess that I snapped it to a wrong RP and draw reference plane. Yeah, that's fine. Okay, done. And go to 3D, and we can have the customization of the grid the same way that we did for that two curtain wall, where in curtain grid, just randomly define right now just to save time. And this would be, let's say, 2 feet. Okay. And herein, for this, you don't need to, but for this, you need to make this unpin and say that just host that particular door, curtain wall, glass door front. Yes, fine. That would be access to that HR. Yes, that would provide the access to this particular area. Clear? So done. And I forgot to let me just click undo and just say that mullions, all grids, and also this. So here there are two of them. Press this and delete. Okay. And herein, I guess that we need to divide it a little bit. Let's have some play and mullion, snap it. Okay. HR. So clear. Now we need to hide this particular restroom, washroom area with the help of the curtain wall. How we will do it? I will just go to this particular Plinth level, and herein I'll just say that WA and curtain wall, washroom, straight roof. Okay, and washroom, sloping roof. That would reference this terracotta tile jali screen. Fixed distance 6 inch by 6 inch. Okay, that's fine. Base offset to be 9 inch, and this to be terrace plan with the top offset of 15 inches. And let me just create from here to here one, and no, I need to check this particular within this. Actually, let's find. Let's actually there are terracotta tile also have design, and there are this particular straight slits also. So for terracotta tile, I need to just check that what is the constraint. Yeah, fine. And six distance 6 inch by 6 inch. Yeah, everything is fine. Base offset 1 cross 3 and top offset 9 inch. Yeah. Then why is it creating a problem here? Wherein if we just check, then it is not perfect. Maybe because the this is not round figure. It's 3 feet 6 inches. If I just change, that will appear properly. Yeah, fine, done. Okay. And let me just go here and change this material part. Where is it? Mm, material part. No, but that is referencing a terracotta tile. So under this family section, expand and look for terracotta jali screen curtain panels. Go to edit type properties, and yeah, herein sash. Apply and okay. Fine. Perfect. And herein I'll just come to this particular plinth level and just make this 4 feet, not 4 feet. Actually, 3 foot 6 inches is fine. And CS and define one from this point. That should also be in multiple of 6. All this pertains to parametric modeling because it is referencing a terracotta tile. So why this got flushed inside? Yes, probably because it is a wall. So that's why modify and just go to this particular wall join and just change this particular joining option and say that disallow join. And with this now, if you just click and if you snap, yeah, okay, fine, it's done. Now just snap here and just click allow and click allow again and just extend this and TR and join this to this. That will flush it properly, but eventually we might have lost this connection at all this stage and we have to do that at all the levels. So yes, and yeah, okay. And you see that this has joined in the wrong way. So let's say that disallow join. And then again, first click this particular and extend and click this as well. Snap it. Okay. And just say that allow, and just click this, extend it. Yes. And then just join it. Fine. And then just do the same for this two junction. Okay. And this is how you have to rectify on terrace plan also, wherein you need to change that allow and allow, just extend this wall and TR and join this to this. Okay. This is how we have made this connection proper at all the levels. Okay. Only thing is that now we need to select this particular, both the curtain walls, which is having that terracotta tile, and just change its base constraint to ground load level and giving it a offset of 15 inches. Okay, assuming that the element to support it is already constructed at that particular 15-inch level, bringing up and flushing it up to the level of this particular grass. Okay, so now what we need to do is that we need to complete the this particular curtain wall just like this. We need to place it here in this particular stair cabin. Okay, so what we need to do, we need to just go to length level. Yes, okay, and just take this particular section over here, flip the direction, okay, and say that I want to visualize only this much, and just go to architecture and first create the wall cut, at all the levels. That would be 8 foot, okay, and roughly adjust it in center. Yes, now this is in center, okay. And if you just go to that particular section and try to copy to clipboard, align to selected level and to first level, it will not create. Say the rectangular opening doesn't cut as host. So this ways you cannot copy the cut. But what we can do is that base constraint is plinth level. So base offset should be 6 inch and top constraint first floor and minus 18.5. Fine. So that would be the cut, and we have to perform the same cut at all the levels. So I'll go to first floor again and then say that wall and just perform the cut, or it's going out of host. Make it 8 foot. Yeah, roughly adjust it in center. We will then adjust it in elevation. Don't worry. And just give it a constraint of, let's say, top offset to be minus 6 inch, base offset to be minus 6 inch, and top offset negative 18.5. Okay. And then go to terrace level, perform the same cut, wall cut, and yes, just say the base offset to be 6 inch and top offset to be negative 18.5. And we will adjust it in elevation section one, sorry, section. And then from first floor RP, I will draw one reference plane all the way. Take this reference plane and let it intersect all the levels RP and select this, snap it. Okay, and now select the cut and roughly just make it snap to this particular HL, and it should select this particular, and yeah, roughly not exactly snap, but that would be enough. And you can change it to 8 foot. Okay, and likewise, this too, you can just adjust roughly and then make it equal to 8 foot. Yeah, that's fine. That is how. Okay, and now just come to plinth level, and herein just say that WA and curtain wall for stairway, curtain glass wall stairway edit type, and it's already hosted with the vertical and horizontal mullions. So as soon as you will divide it manually, it will host this particular mullions. As far as the interior type is concerned, it will host this one end square, and as as far as the border one and border two is concerned, for both horizontal and vertical, it will host this size of mullions. Okay, so I will again go to section one, and herein, no, sorry, at plinth level only, I'll just say that wall, and with that selected base offset to be 6 inch and top offset to be negative 18.5, but the top constraint should not be terrace level, but it should be slab top. Fine, and I will just create by space. I will just create that particular curtain wall from here to here. And then if I just go to section one, you see that HL and R enter, that is realistic. The curtain wall has been created. Yeah, fine. Okay. Now time to divide it. So just say that curtain grid and just roughly 1 foot 6 inches and 1 foot 6 inches, 1 foot from here, and wireframe. I need to see the division so that I can divide it accordingly. That once I divide, the grid matches with the structural division, and 1 foot and 1 foot from here, 1 foot. Yes. And here, if you want, you can create division. So this would be the division of the this particular curtain wall. If I just go to 3D, then you see that it precisely follows the division of this particular structural element. Fine. That you can decide it, the division, you can decide it on your own also. That's fine. Okay, so that's how we have created this particular curtain wall for that particular stairway. Fine. So now what next is that we need to we need to create the roof for this particular pergolas. Again, the curtain walls for both of this. Fine. So let me just go to terrace plan, and let me just say that let the range base level should be first floor. So with that, I'll be able to, it's not laptop, first floor. I'll be able to see this particular thing, HL. Fine. And for range base level, yeah. Okay, so first let's create the curtain wall. This is also again a curtain wall only. If you just watch this particular thing, and this is just a curtain wall, but it is a sloped glazing. Okay, it is created with this particular sloped glazing function, which has the same options like curtain wall. Okay, so this also I have copied from that particular from this project to that particular project. So I will just go to roof and say that roof by footprints, and I will just draft this boundary and create this what highlighted lines overlap. Yeah, that's fine. I would just like to say that pick and join this to this, join this to this. TR, and then I'll say that pick lines 1 and 2, 3, join this to this, and TR, sorry, I need to pick this, I guess. Okay, and then say that TR and join this to this. And for all these lines, also I need to close shape over here. For all these lines, I will say that define slope uncheck, and roof one, I'll just say that sloping glaze for terrace relax area. It's already, I have copied it from that particular file. It is nothing but the sloped glazing. I have just this particular sloped glazing. You will find it on your file. You will just duplicate it, edit type and duplicate, and just say that grid one to be fixed distance 1 feet 6 inches, 18 inches, or let's say that 1 feet 15 inches, whatever, and 15 inches. But if it's 1 feet by 1 feet, then let's make it that only. Fine. And for the grid one mullions, for the interior type, I will just select this. I will just say that interior type should be 1.5 cross 5 for rectangular sloped glazing. Copy, and border one and border two none. And here also I just say that 1.5. Okay, and fixed distance 1 foot by 1 foot. Apply and okay. And with that, if I just finish, lines cannot intersect each other. Yeah. Okay. So I need to close after a close shape and finish. Wow. So that's created at that particular designated level. Clear? So that is how you can create this grid. And likewise, you need to create it for this as well. So for that purpose, I will just go to first floor and say that the range level should be plinth ground floor, plinth level. And with that, we can see that, but we can see a lot of elements. Actually, the AutoCAD plan is not needed. HL, but that's fine. Okay. So again, I just go to this roof by footprints, and this time I will select stove the glazing for multipurpose room pergolas. Okay, this one. And if I just go to edit type, then the fixed distance is this. Okay, and grid one, again, I will select the same for sloped glazing, copy and paste. That is the different type of mullion. I have just created it 1.5 cross 5 inch. Okay, but this time the fixed distance would be 18 inches cross 18 inches. Apply and okay. And I will just create this particular boundary line by snapping to the lines 1 and 2 and 1 and 2, 1 and 2 and 3, TR, and trim the faces and just connect it. Okay, select all of this and say that define slope uncheck. And with that, just change this to 45 cross 45 and just finish. So let's see. It didn't create the grid. That's strange. Slope decreasing. Yeah. Why didn't it create the grids? 1 feet 6 inches and 1 feet 6 inches. Oh, offset, not offsets. Sorry, guys. I made 45-degree and 45-degree. So that will create those mullions and that particular grid. Fine, clear? So now what we need to do, we are completely done. What we just need to do is that have an elevation treatment on this wall and on this particular wall, and that would be really easy. So I will just go to this particular plinth level and take this particular section a bit far and say that RP, that is the reference plane, and select this. Okay. Also, I will create this reference plane over here on this face, take this particular section and just flip it. Okay. And I would just say that component and model in place, walls, and that would be elevation treatment. Okay. And just go to set plane, pick a plane, pick this particular plane and go to section 2 and HL, and quickly I say that create extrusion, and I would just select this and also this, but I would say that offset to be 1 feet on either side. And herein, I'm just going to create a profile in such a way that we can later incorporate a flower bed here. So that would be offset 1 feet from here also. And this is already 1 feet. That's fine. So in that case, this should be mm, not 1 feet, offset 9 inches. Okay. And 9 inches here as well. Okay. And then this would entirely flush with this surface. Yes, that is the surface. And now herein, I need to say that select this, pick lines 1 and 2, TR, and join this to this and this to this. And yes, okay. So that will exclude that much part. 1 to 2, TR, and join this to this. Okay, and also split, join this to this, and split, join this to this. Okay, and let me just slightly take this. Yeah, fine. We'll do that later once we place the flower bed. And here, this should equals 1 black stone. Yes, it was that same material, black stone. Yes, this is the material. And okay, I'll just say that finish. Client must be in closed loop LI. I need to connect this and then say that finish. Where did it create that? Okay, it's created perfectly. The extrusion start should be 0 and extrusion end should only be 6 inches. That's enough. Go to 3D. Yeah, with that is created. Now we need to create that same face over here and then create the flower bed. So I'll just go to plinth level, and this sign I would say that PK, that is PK, and pick this reference plane and go to section 1 and HL and create extrusion rectangle and just say that align. Okay. And herein I would just create something like this, maybe which would act as a niche, 4 inch, some cutouts within that, and press OK, and just say that copy 1, that's too far, and just say that copy from this point to this point. Yeah, that's fine. Okay, and this would also be 6 inch. That's fine. And finish 3D. And yes, that's done. Okay, so that is how you can create elevation treatments with this drafting. And now the last step is to host the flower bed to this, to section 2. And again, I'll say that create an extrusion that would be rectangle from here to here, but this time it would be 0 and let's say that negative 15 inches, and likewise here too. Okay, and just say that finish. Let's go to 3D. Oh, not negative. Let's say that positive, and that would equal to the material of the wall, the finished material plaster. Yeah, fine, that's okay. Perfect. And now how to create a flower bed here. For that purpose, I'll just go to this Plinth level and create and void forms and void extrusion and create one with the offset of, let's say that minus 3 inches. Create this and say that extrusion start 0 and extrusion end 2 feet. And we will adjust that in section, its location. Oh, not this section, wherein this should be this high and yes. Okay. And then just say that CO, copy it from this end, constraint uncheck, and copy it to this. Okay. And with that, now I say that cut this. First, I'll say that cut this to this. I'm not allowing to. Let me just go to 3D. Oh, yeah, that's already created. You don't need to cut. Okay, fine. So that is how they have created the flower bed. If you want to change the base, then you just need to go to that particular section. And for that, both just change the base, this particular thing, change the base, and also this, change the base. Okay, fine. So that is how I created the flower bed. Fine. So now I have to quickly create this particular elevation treatment, which is absolutely similar only. I'll just go to Plinth level again and I'll just finish. But I'll take this particular section over here, flip the direction, and take this section over. Sorry, this section over here. Yes. And to reference plane, 1 and 2. Just get rid of this reference planes. We don't need it anymore. Okay. And I would just say that we are still in that, no, edit in place. And we are now in that particular drafting mode. And just say that create set plane, pick a plane, pick this particular plane and go to section 2 and create HL and create the elevation treatment extrusion. Here there will be a flower bed. So I will just say that from here to here and should match this RP, select and done and triangle and just get rid of this 2 windows. Okay. And this line 1 to 2 and 3 and 4 split element tr, join this to this and join this to this, and let's say the extrusion start, extrusion end. Let me just go to Plinth level and let's see where it is extruding. Yes, fine, but this should only be 6 inches. That's enough. And now I will just say that pk and go to section 1, this particular section, and then I would create extrusion which would start from somewhere over here, connect tr and draw lines 1, 2, 3, 4, and likewise this extrusion end. And where did it create? Yes, so this would be negative 6 inches. Come to 3D, okay, and join this to this. But for both of this, join this to this. And why is it? I guess that section 1 and snapped to the wrong line. Yeah, okay. But for both of them, the material would be one black stone. Yes, the existing material, so it would accept. Yeah, perfect. Okay, and then just say that we need to create the flower bed. So this time I'll just go to section 1 or section 2 first, and then I'll say that create an extrusion. Again, create this extrusion till this point. Okay, and fine. And let's say that extrusion start 0 and extrusion end would be minus 15 inches. Finish. Where it create, not not negative. This is always trial and error. Fine. And the material should be one plaster. Okay. And I'll go to section 1 and create that same here as well. Create an extrusion with that same negative 1 feet 3 inches. And where did it create? Yeah, perfect. Okay. So just join it, this to this, and one plaster, one plaster. Okay. Okay. Now we need to create the niche for that flower bed. So plinth level and not plinth level. Go to first floor, and yes, I'll say the create and void forms and void extrusion, and with the offset of 3 inches, negative 3 inches, I'll create this rectangle, and with this, yes, and TR, and join this to this, and join this to this, and we'll adjust it in the section 3D. Where did it create? It created in the wrong place. So go to section and just extend this, and this should be somewhere over here, and go to 3D. Okay. Yes. So that niche has been created. Okay. So that is how you create this beautiful elevation treatments with the help of different drafting commands. Okay. And now what next is oh, this I forgot. So let's just quickly do that. Let me go to terrace level, terrace plan. Yes. And herein also we will have, just like this, we will have so architecture and WA wall, and that would be curtain wall for, let's say that, which what it would be, curtain wall for, mm, oh sorry, not curtain wall, sorry, roof and roof by footprints, and that would be, yes, sloping glaze for terrace, yes, and just say that we don't have anything, fixed distance 3 foot, yeah, that's fine. So the division here now this time is 3 foot. And what I would do is that within that 3 foot, I would just snap it from this point to this point, and also from here to here. But that, do I need to create it differently? Yes, fine. So first let's create this and just say that define slope uncheck. Let me just check it in that project, whether this was uniformly created. Okay, I I got rid of the beam at this particular point. So with that, you can be uniformly created. So just say that no, and I will just go to 3D, and this beam is not needed. So I will just delete it, and then I'll come to terrace plan, and then say that roof and roof by footprints, say that slope the glazing for terrace, just snap it from this point to this point, and then say that pick lines 1 and 2, TR, and join this to this, and just delete this line, and select all of this and define slope uncheck and finish this. Okay, so that will create this fixed distance 3 good, but I forgot to snap. So again, this would be the same, copy interior, and interior, apply and OK. Yeah, it's fine. So you see that if I just go to 3D, yeah, OK, clear. That particular curtain grid has been created. This should be curtain panel in this case should be empty because within that curtain panel, I am going to host other different curtain panels which would act differently, having different angles. I'll just show you. So if I just go to terrace plan and thus I say that roof by footprints, we have already created this sloping glaze for terrace. Now I will of that I will just select this sloping gray embedded for terrace. Okay. And with that, I will just select this boundary. Okay. And select all of this and say the define slope uncheck. And if I just go to edit type of that, the fixed distance is 3 inch, and that should reference this smaller mullions. Where is it? 0.5. Yeah, circular mullion. No, not this. Where is that? Mullions. Just a second. Yes, and edit type, and that is referencing rectangular mullion 0.25 inch, which was not copied. Okay, so that's fine. We can just create it quickly. I will just say that discard this, and first I will just drop down, and herein I will try to find mullion, curtain wall mullions, drop down, and under rectangular mullion, I will just say that type properties and duplicate this, calling it 0.25 inch, and I should have checked. Let me just select this family, expand the family section, and they say that the curtain wall mullions, rectangular mullion, and 0.25 inch. What are the type property says? Minus 1.5 should be the offset, and this width on one side one with 3 inch of thickness. Width on side one is 0.8, 1/8 of an inch and 1/8 of an inch. Okay, so 3 inch of thickness, and size should be 1/8 of an inch, 1/8 of an inch, and this should be offset parameter pertaining to displacement in the y direction should be negative half, negative 1.5. Okay, negative 1.5 or positive type properties, negative 1.5. See, yes. So with that, negative 1.5. Okay, apply and okay, and then I would just say that now I would go to terrace. Where is it? Roof, and roof by footprints, and then select that particular sloped glazing embedded one, sloped glazing embedded for terrace, edit type, and herein I will just select this to be the one that I just created, copy and paste and apply and OK. I will just select and get rid of define slope uncheck, and this would have only this, only this mullion one, grid one. Okay, grid one, fixed distance 3 inch, only one grid. Apply and OK. And with that, I'll just finish. Just go to 3D. Yes. Okay. Now, what can you do? What can you do to this? Is that let's me just select this and say that this is the slope deglazing embedded for terrace, and this should also be empty. System panel empty. Apply and OK. That's fine. Okay, perfect. Now, what can we do to this? You can reference this along the different punctures and have it a different values of angle for them, degree of angle. So how can we do that? See, if I just select this, copy, all of this are same, 1 and 2 and 3 and 4 and 5. Okay. I will just select this and just change the degree of angle. Let's say that 45. Select this and say that 15. Select this and say that 60. Okay. And for this, I would just say that 15 or 15 is already done. So let's say that 75. Okay. And likewise, you can create different pergolas resting at different angles for this particular grid ceiling, just like this. Okay. I have created this entirely that ways only. Fine. So with that, now what left is this to define this earth and this road, and that is pretty much easy. I will just go to this ground level floor plan, come to 3D and sorry, not 3D, plinth level plan, and just say that turn on this bulb. With that, I'll be able to see this AutoCAD plan and unhide in view. Oh, that is already unhidden. Why cannot I see it? Oh, yes, HR. And take this drawing and just change it to ground road level. So we can see it here, HL, but in this, it is hidden by category. So just unhide it and turn off this bulb. And yes, now what I need to do, architecture and component and model in place and site components, edit type, just say that site, okay. And I would just say that extrusion and I would just pick lines 1, 2, 3, and this would be extrusion start 0 and extrusion end would be, let's say that -2 inches, and this would be material would be asphalt, or let's say gray, so that will asphalt pavement dark gray, okay, and just finish. And another, I would just say that create extrusion, which would be, and from that I will just get rid of 1, 2, 3, 4, 5, and this entire profile, okay, and TR and join this to this, TR and join this to this, and this to be -2 inches, that's fine. But the material would be earth, and just click it, okay, and finish. Quit sketching. Oh, sorry. No. Where did I make a mistake? Somewhere it has show. Ground road level. Uh, lines must be in closed loop. Continue. Yes. Where are there overlapping lines? I cannot see it. And are there any? No. Mm-mm. Show. Which is that overlapping line? For simple thing, it is creating a problem. Ground road level. Oh, yes. Somewhere it was popping up. Okay, fine. So with that, I'll just say that finish. Go to 3D. Okay, and we have created this earth and road network. Okay, so with this, we are done entirely with this particular project. Now, if you want to add human figures, trees, everything is within the Revit interface only. For example, if I just go to component, then if you just drop down, you see that you can load. There's different types of trees which are available here itself. If you want to add human figures, then just go to insert and load family, and here in English Imperial, within this Autodesk, your version, and within that libraries and English Imperial, the unit system, whether metric or imperial, you just need to go to this enter age, this folder, And from there, you can add this car, you can add male, female, human figures, etc. Okay. And apart from that, if you, what else? Human figures and yeah, yes. If you want to add street lights, then just go to this lighting, architecture, external. Herein you can add this street light, which I have added. Fine. So that is how you can just add use the existing library of Revit and add the different elements to this particular project. Fine. So this was talking about the modeling part of the 3D interface. But as I said in my introduction, if I just go to this particular sloping roof, so you see that it gives a totally complete different options wherein you see that these are the actual the roof tiles. These are the actual roof tiles which has some thickness. Okay, this is not a material. And all the parametric elements and parametric openings and all this particular thing, everything, you see that this is the complete different option with sloping roof. Okay, and within this you have this classical Roman style windows and likewise everything. Okay, so if you want to learn all this which exists within the 2D interface also, everything up to this particular sheet composition, that how can you create this particular sheet composition sheet with different drawings. You see that there's different drawings of different discipline and different scale has been compiled together like this. Okay, just like that, you can have this different types of schedules also pertaining to your building with information feeded. I have shown everything of this in introduction, just showing you again. So all of this, if you want to learn, then just enroll for this course. Master Diploma in Revit BIM, which is a combo of architecture plus structure plus MEP. And let's learn together and let's grow together. So watch this entire tutorial till the end and let me know if you have any doubts or queries in the comment section. And I have to try to reach up to each and everyone solving their doubts and queries. Okay.